everybody. My name is Darius, and I'm one of the founder of a company called Visualix from Berlin. We are 15 people, and we focus on large-scale mapping and localization for enterprise. In this talk, I don't want to really go into the technical part too much, but I think it's very important for everybody here to sort of get a feeling of what the AR cloud really can bring, what use cases there are, and what requirements they have towards the customer side and also on the tech side, because there are a lot of bifurcations, different avenues you could actually go in for different AR clouds that correspond to different markets and different use cases. So here I will share a few learnings with you that we have made in the last year and a half that really sort of illustrates different use cases for different customers and really to dig deep into what the value is of this technology. So a little bit about me. As I said, I'm one of the founders of Visualix, and we developed a visual mapping and localization platform that enables large-scale AR. So basically expanding the area of mapped space from, let's say, 20 square meter to about 20,000, being able to cover an actual factory floor and localize with centimeter precision. That's sort of what we do. And yeah. So a little bit about augmented reality. I think we all know that the basis for an AR cloud in some sense will always be mapping and localization. Basically, you map a space. I conveniently took this image from Google. Maybe I should have taken this, but it's a pretty cool image from Google that illustrates how it works. You map a space, you attach content to a space in the physical X, Y, Z coordinates, and basically from there you can localize and see the content at the same position. So this is all pretty cool, and it targets certain use cases in the gaming sector, perhaps sharing AR content very locally. Maybe 2-3 people can see the same AR content in the same spot. This is what HoloLens, for example, beautifully shown. However, there is a whole class of different use cases that could be built and approached if you had certain other requirements. And the problem that we face is that augmented reality is still very local, 20 square meters, but it should be sort of expanded upon, because a lot of use cases only really work if you have a map, a physical, an AR cloud map that really covers the actual space, and every spatial relationship from one point to the other is covered and connected. So meaning you need a visual mapping and localization platform that actually works at scale and doesn't, and it's not like a carpet of different little QR codes that are spatially put together. There are a whole class of use cases that only work if you have a map that is really very large. Other problems that AR currently has is the drift accumulation. If you, let's say, walk 10 meters, you will always have a drift that accumulates steadily, and for that reason you will have a shifting in the experience, and after certain, let's say after 30-40 meters, the experience becomes not good anymore. So you're always limited by the limitations of the device that you have. Another thing that I haven't mentioned here is the robustness. Robustness is a very big problem. I mean, if you want to localize, let's say here, let's say I had a phone or a HoloLens or some other device, and I just want to hold it up here and localize. It wouldn't work because the technologies that are available on the mobile device today, and also likely in the future, are capped. ARKit, ARCore, which are amazing, of course, but they have the limitations since they only grab about 2 to 3 meters of the feature points that are from the distance of your phone. And this has to do, of course, with the computational limitations of the device, because you don't want to grab too many points to incorporate in your localization. But we found that if you really want to go for this large scale, you need, of course, to be able to robustly localize even if the wall or the features are 20 meters away. And that is a very important thing that has to be done before these use cases can be addressed. So this is what we have achieved finally. We have been working on this for two years, and we have now a mapping and localization platform that really can expand the map from 20 square meters to now 20,000 square meters. That means we can comfortably cover a factory floor at Siemens or Trumpf, whatever, and are able to localize with very high accuracy. Also, what is very important is the drift problem. we sort of circumvent that by always continuously localizing. So we don't localize at one spot, walk 20, 30 meters and don't do it again. But because the error always accumulates, we always localize. And for that reason, we correct the drift and correct ARKit and other local tracking technologies. May it be AR core, may it be spatial anchors. We just sort of need a 6 degree of freedom tracking, whatever it is. And on the back end, our own technology runs. So yeah, to actually do this, I will later go into it. We actually divert all the computation to the cloud or to an on-premise server at the moment, because that's the only way to really get this large scale going. And I will maybe talk about it later a bit more. So here I would like to share some nice lessons that we learned. So this actually took a while to learn, but perhaps I can go into certain use cases. This this might be interesting to you guys. So we target these three sectors: logistic, retail, manufacturing. Construction is also something interesting that we want to approach in the future. So in terms of localization, in terms of logistics, our technology, or any AR cloud technology, can, of course, be used for the AR itself or the localization itself. Yeah. So we have these two enablements, which are slightly different. Same technology, but different markets, different problems that are solved. In the logistics side, we're experimenting with forklift companies, with other automotive companies who want to only have the localization. So they are not interested in having beacons installed where you need 1,000 beacons at a high density to actually get the accuracy, but they only want to do it visually. And they only, and also with changing environments, which is very important. Picking optimization, that's a very interesting topic in logistics. That ties into the localization, but also for AR, you want a person working at a large retailer to be able to actively know where is the optimal route for me to go, where is this one product from a portfolio of 50,000. These are things that take a lot of practice, takes a year or something for a worker to know that, but of course those workers don't necessarily stay that long, so you really have to quickly, they need a platform that they can immediately use. So you localize in the market, you see exactly a tray of different products that you have to put in a tray, different products that you have to put in a tray, and then you're led with AR navigation exactly to the right products very quickly. So that's one. On the retail side, I mean, indoor navigation is sort of a given. Point of sales experiences that are not local, but sort of engage the customer not only on the one spot, but also connects this journey to buy certain things from one end of the store to the other. Also tying, for example, the idea of buying a printer and finding the associated, what are they called again? Cartridges? Yeah, cartridges. And just basically creating sort of bundled offers that are very interesting. And for this, you need sort of the spatial component that allows you to track yourself from one point to the other. Inventory management, that's of course as well. Manufacturing is, I think, one of the most exciting use cases because there's a lot of variability here. Maintenance is a big topic. You want to immediately go into a large manufacturing hall. Maybe the worker has never been there, but with AR glasses, you immediately want to see, okay, this is a spot I have to maintain. This is the first thing I have to do. This is something I have to check. And this is something where our technology really helps, and we see the largest use case. So maintenance, factory planning is a huge thing, where in an empty factory, you want to overlay the augmented 3D models, the cut models of the factory, in order to see the spatial arrangement. You want to understand, okay, is this placed correctly? Oh, maybe not. I have to move it 30 centimeters to the left. Oh, I have to actually change the air duct. The architecture has to be planned differently. So all these things you kind of now see after the fact and have to be sort of costly, at a very costly fashion change, but with our technology, companies can just basically see it and then understand and plan much better, in a much better fashion. Workflow management, that's a very important factor we're seeing now in the construction space, basically where it connects the worker to the whole plane, allowing the worker to say, okay, I have to go here, pick up this certain item at this time. I have to go to this machine and put this in and fix there. Then I have to do, these processes are all spatial, and that's something where you really need one unified map to actually do this. Digital twin creation, mapping in itself is also a very interesting topic. Feature points to localize, that's one thing, but of course some companies want the actual 3D feature map, yeah, like a Navis style map, like Matterport. That's something they also want. Since we have the images and the poses, we actually can do that, and we are slowly experimenting with this, and with some very nice results. I unfortunately can't show this yet, but this allows a factory to basically just walk through the factory and map it in a really 3D nice fashion for them to plan. Why do they need to plan it? They need their customers to actually map the space for them to understand how they can fit their machines that they want to sell to the customers, and how to place it, how to transverse the different areas of the factory. And currently they use other mapping technologies which are quite costly. They are sort of large devices that you have to carry and basically walk through the hall. And that's something that really is not a scalable solution. So they're looking for an app that basically just you give to the customers and they scan it themselves. Of course, there are a lot of AR companies that we're already approaching, very large ones who have already a deployment of 12,000 or 13,000 apps, where we are currently validating and experimenting how we can really go forth in the best fashion. Covering all of this. So these are market segments. I haven't had a slide with sort of devices, but the future is of course going to be in AR glasses. That's clear. And AR glasses have to be light. They have to be come under price point of 1K for industrial clients. This is also very good learning. And for all of this, you need something that cannot compute the pose in a very large environment. So here, a server-side computation is necessary to do this, and we are pushing for all the major manufacturers of those glasses for them to integrate this. So this sort of ties into what we do. This is just our belief, and this is the path that we chose, sort of having a hybrid solution that combines the local 6-degree of freedom tracking, be it whatever, AR kit, we take the pose from that. We don't take the point cloud, but we actually create our own point cloud from images we stream. We have a few patents on this. This is our approach, but of course that's not the only one. Yeah, we believe there will be many different avenues. Here I want to show you how it actually works, how it actually looks like in real life. Let me just... So here's a video of the mapping process. So here we attached a phone on a forklift. And the forklift just basically drives around, and so the forklift with the telephone drives around. We stream continuously the images to the server. On the server, we create our own point cloud. You may see these blue dots. It's not very easily seeable, but on the right side, you see the camera pose. You will see... Maybe it will be more apparent now. Maybe you see it better now. Yeah, so there are these blue points on the right side that we later can localize against and find the pose and the position of any camera-enabled device. So the mapping has to be done, of course, with a phone, because we need, as an input, the 6-degree of freedom tracking, but the localization itself could be handled by any camera-enabled device. And I might just maybe skip this and make it a bit quicker, because it's quite a big space. Here we return back into the factory. You can sort of see the plane that we actually scanned. And you will see that a drift has accumulated, of course, because it's a huge space. Maybe faster. And here is this other very important enterprise requirement. You want a consistent, unified map. It doesn't help if you sort of have a map that is not connected. And this is why we do our own loop closing, our own technology on the back end that corrects it. And you will see this, I think, now. Yes. So it's connected. And now we have like one ground truth onto which devices can localize and experience augmented reality in a very accurate fashion. So that's the mapping process. Okay, and then we have, this is like a simple video. It's not very beautiful. So as you see, we are not designer people. We're not very hip and cool. We're not 6D, okay? We're not 6D. But what you see here is localization that takes place in seconds, even in a very difficult large-scale environment. We have the navigation arrows that we continuously correct the pose. So basically, every second we stream like 2 images to the server to correct the position. And like this, you sort of can have unlimited navigation. And if you would only do this, let's say, with AR kit-based technologies, you would, of course, accumulate a drift. And here we walk for, I think, 800 meters or 200 meters. And end up exactly at the entrance of the door where we place the content. So, let me just go back. Yeah, that's it from my side. If you have any questions, just let me know. Thanks.
All right, thanks for the introduction. I don't know how familiar some of you are with the name Croquet and our CEO, David Smith. Like Nick mentioned, I'm a local here, and I got to know David only in the beginning of this year and kind of knew about his background as being one of the pioneers of AR, and I think I even saw some really old screenshots of some version of Croquet at some point. But basically, his mission since a long time has been to build an AR, VR operating system. And when I joined Croquet earlier this year, they were working on porting that to the web platform using Webgl. And a big part of what David is thinking about is really that AR and VR can be a communication platform. And looking at the demos which they had back then, we kind of collectively realized that the most interesting ones are really those where you can collaborate in space and where you can collaborate in real time. And that's really where we see the potential, that you have a truly shared space where you can work together. As we also saw from the previous talk, I think there's a lot of focus on the spatial aspects of a shared space to make sure that multiple devices really see the same reality from the same point of view in space. But we realized building our demos that the time aspect of that is just as important, that you need really low latency, you need to see exactly the same things going on. So what exactly do we mean by live collaboration? Well, this idea that you see exactly what I see. So if this doesn't work or if this breaks apart, then we don't have the feeling of being in the same space. And that implies, of course, that whatever you do affects me and what I see instantly. And ideally, this should work across devices and platforms. There's now kind of an evolution of a lot of real-time collaborative apps and games popping up, but we really think that they're barely scratching the surface. Like, there's a lot of startups now that are some old idea plus live collaboration. Probably the newest example for that is Figma. You have, of course, classical video conferencing, multiplayer games, classical collaborative document editing like Google Docs. But these are all like pretty specialized companies who had to spend a lot of effort to even build up the infrastructure to support live collaboration. And they kind of had to each duplicate their efforts. And in this environment, a lot of developers would like to build collaborative apps, I would assume, especially in the AR sector, because again, the most interesting AR apps are probably the collaborative ones, but it's just so difficult to do. You need the resources of one of these big companies and basically build it up from scratch. And we kind of pivoted the focus of Croquet to really be about this part, to make the real-time collaboration really easy to do. Just again, mentioning that it is way too hard to even do something as simple as collaborative text editing, let alone any more interesting form of interaction, either in classical web apps or 3D applications or AR, VR applications. So what's different about the Croquet model? Here you see again the live collaboration, but what's going on in the background if you're using Croquet. So the main thing which we did was we built up an infrastructure that we call a stateless edge cloud that consists of so-called reflectors. That's the thing that you see on top there. A reflector is basically a very lightweight server that does nothing more than to kind of take in the events that are coming from the different devices and ordering them in time and sending them back to all the devices. So that means that all the user actions that are coming from the different devices with potentially slightly different latencies because of where the devices are located get one consistent order and like one true history of what happened in this shared world, which is then being broadcast to all the participating devices. And the essential part is that each of the devices kind of redundantly do the computation of the world based on these events that are coming in. And we built some libraries and support to make sure that all computation that happens on each of the devices, even on different platforms, happens deterministically, so that with this shared history of events that happen in the world plus the deterministic computation, you really get this perfectly shared world. But you don't need to share the whole state of the world. You only need to share the events that affect the state. I think this will become a bit more clear when I show you some examples later, but what this means is that it's really, really cheap to build the infrastructure for that. Right now we're paying like tenths of cents per user per hour for our reflectors, and it will probably drop even further with scale. One interesting implication that this has is that you don't actually need to write server-side code to drive collaboration. All your business logic or game logic exists in the client, and the live collaboration and sharing of state just happens automatically if you adopt the framework. And kind of as a side effect of that, when a new user joins, Croquet also takes care of sharing the current world state once, and then this user just also receives the small changes to the state like all the other clients. And because these reflectors or these very lightweight servers are that lightweight, you can really have a lot of them, and you can have them very close to the user. That's why we call it an edge cloud. So we're hoping that by deploying them on a really large scale, there will always be a reflector that's like less than 10 milliseconds round trip away from your device. And yeah, another side effect of the reflectors being that lightweight is that you can support a lot of users on each reflector, especially in scenarios where you have like a couple active participants and a lot of participants who are more like viewers. And the use cases we have in mind there is something like sports-like events where you have some, for example, esports players interacting in a game and a lot of viewers of the event. And well, our plan is to have thousands of reflectors within this year kind of distributed over the globe and then to scale it up even more from there. And again, because you only need to share between the reflector and the devices the events that affect the world, these events are usually very tiny. Like you can have really simple user events that have quite interesting results in the world. And again, you'll see that in the example in a second. But the thing you have to share really only is the event, and that's really small, and that also means that the bandwidth that has to be available is really small, which helps with mobile applications and, again, with the server costs. And as a last thing, these messages are encrypted, and the use of reflectors is anonymous. The interesting thing is that, as I'm sure you understand by now, there's no application-specific code in the reflector at all, so we can reuse the same pool of reflectors for all the applications out there that use Croquet. And the reflector also really doesn't care what the messages that you send it mean in your particular application. So they can be encrypted, and they don't even have to be associated with each user. This is probably a good point to actually show you what that looks like in practice. Let me see if I can get this up here. So here we have a Webgl-based physics demo, and you can see I can interact with it. Let me see, I can barely see my mouse. I can drag these pegs around and kind of interact with the world. And so far this just looks like and is actually written like your average client-side web app. But if I now go ahead, sorry, that's a bit tricky. me create another window over here and bring it over. So I'm basically just opening a second instance of this page. And as you can see here, if you kind of look at them next to each other, I mean, they are running on the same computer, but this is just a coincidence. You can see that they are perfectly in sync, and all of the things that are happening in the world happen at exactly the same time. If I now go ahead and, for example, move stuff around as this user here, you will see how, again, the worlds on both ends are affected in exactly the same way. And this is maybe a more understandable example of how the only thing that I need to send to the reflector is basically my events of like moving this keg around. What I don't need to share between the clients over the internet is how this complicated chaotic physics simulation reacts to that. So that's just replicated perfectly on each client because it's computed deterministically based on this shared history of events, of things that the users do to this world. Now, to make this demo a bit more interesting, I would invite some of you to actually go ahead and try to scan this QR code here, and on your phones or tablets or laptops. The URL is a bit unwieldy. I don't want you to try to retype that, but just try it out and see if this opens up for you. And you should be able to, now I'm getting these messages here which hide the QR code. Yeah, you can see some people are already moving those around. And you should hopefully see, looking at your device and the presentation screen here, that it's also in perfect sync. And probably we should both be connected to like our European reflector right now, so the latency should be quite good. And at least when I interacted with it, I didn't feel the delay between me moving the mouse and the round keg moving around. Ooh, someone managed to change the background color. Okay, so another demo that we can look at is, like, this illustrates quite well, again, the point of only having to share events between users and having a quite complicated world state, in this case physics, but we wanted to take it really further and show the potential of our platform. So we were actually lucky to have a game developer join our team, and he has been working on a game prototype which is based on this voxel-based world. It's kind of a strategy game where you control a village of entities, and like this is really early on, but what I can do here is I can, well, edit this terrain, can remove stuff or fill it in. And let me actually go ahead and already share that with you guys again. So you can, let's see here. Can you, yeah. You can open it up, and then to interact with it, I'll need to make the QR code small again. And you should first be able to see exactly the same terrain as I can see. Okay, some people are joining. So if I now go ahead and edit it, you should also see these changes as I do them, and you can also try to use the controls. I don't know how well they work on mobile. Yeah, I can already see some other people editing the terrain. So that's kind of interesting, but most interestingly, I can go ahead and spawn some intelligent AI agents. So like in games, you obviously want to have some intelligent agents. In this case, it's like a bunch of dinosaurs running around doing pathfinding on this terrain. Later on, when the game is further developed, these will be kind of your minions who you can task to like chop some wood or build up your village. And you can see that they have quite complicated, let's spawn some more, behavior with like complex rule sets and like I mentioned, things like pathfinding in this world. But again, while they run around, no state at all needs to be shared between all of our devices because the computation is deterministic. So only if someone changes something about the world, like editing the terrain or spawning new ones or telling them to do something else, this information needs to be shared. And then you again have all of these, like quite a large number of agents doing exactly the same complicated things on all the devices. Whoops, someone reset the world, I think. Okay, so going back to my presentation. Just to contrast that again with other existing models that you would have available if you want to build a collaborative app or a multiplayer game, the classical thing to do would be, which I call the classic client and server, where the server is solely responsible for computing what's going on in your world, and then kind of at every tick or at every update of your world has to stream the whole world state to your device. That works, that creates like a consistent view of the world, but it requires a lot of bandwidth and it requires custom server code. Even more intensive is like the Google Stadia model, which helps developers who kind of build their games as a single player game to make that streamable and multiplayer, where like you run the game on a server and you even render the game on a server, so you can also support low power or like devices with not that many computational resources. And then these devices only have to watch a video-like stream of whatever the server is rendering. The problem with that being, like I mentioned, huge bandwidth, and you have also quite a lot of latency because you first need to render it on the server. And on the right, you see, in contrast, the croquet model where the world only exists in the client devices, and the only thing that's shared is kind of the history of events, like I said a couple times now. And because the computation is deterministic, you automatically end up with exactly the same world state. The only case where you need to share the world state in the case of croquet is actually what you saw yourself happen when you joined the session. Well, you need to first get the current state of the world to be able to compute it from there like the other clients. And what happens there is actually a kind of peer-to-peer thing where your device asks all the other devices which are currently in this world to please share the state. So even there, the reflector is not really involved and it scales really well. Here's kind of a more detailed overview of what that implies, but that's a bit too detailed for now. The business model we want to build around this is to basically offer this edge network of reflectors as a service and to really foster the creation of some interesting demos and games. Using the network will even be free to a certain degree, just again because it's so cheap for us to run it. And then based on your traffic and commercial success, we would charge you a fee for using the network. This is our team. I mentioned David Smith. We're fortunate to have people like Alan Kay or Dan Ingalls as our mentors. And we have an early version of an SDK available, which is for web apps, which has already quite extensive tutorials that kind of teaches you the couple small things that you need to know and the kind of development style you need to adapt to work in the croquet model. But then once you do that, you basically get all the real-time collaboration for free, and you can just write your client-side app as a normal like Webgl client-side app, or even just as a web app. We're also working on some demos with more classical like collaborative text editing or like collaborative whiteboards that then go more in the direction of something like Figma. That's all I have for you. If you want to be notified about news for Croquet, you can just go to croquet.studio and sign up for the newsletter. And if you're a developer or if you know developers who might be interested in this, I really encourage you again to check out our SDK, even though it's early on. There's also some more examples. Yeah, thank you very much.
Good morning. Thank you for having me. I have the unique opportunity or the privilege to talk about the future in an optimistic way. Part of the idea of the convergence of bringing together technologies, communications, artificial intelligence, augmented and virtual realities, is trying to think of what they can do and how they can be powerful together. And in fact, today I'm going to ask the question, what if we actually got it all wrong and this stuff could make the world a lot better? In fact, when we think about artificial intelligence, we understand that it's actually changing the world faster than most technologies, in fact, probably any technology that we've made before. And it's not just changing it a little faster. A lot of times it's 10 or 100 or even 1,000 times faster in some industries. And that's really important. And we're not alone in having that belief. In fact, some of the most important names in technology consider this something that is as important as fire and electricity. Even in mainstream media, you've probably heard the reports about how artificial intelligence, robotics, and intelligent systems are going to change the future of work and how people make a living in the future. And even if you don't know the Mind Foundry, you have probably heard the words of our founders. Reports like this are based upon their work. We were actually founded by Professors Stephen Roberts and Mike Osborne, who run the Machine Learning Research Group at the University of Oxford. And with those strong ties to the university, our founding team has been solving some of the most challenging problems in artificial intelligence and machine learning for years, and it's that background that's really led to some of the understandings that guide the company today. And just anecdotally, if you have been in the artificial intelligence space, you probably know Steve and Mike's work, and if you have been trying to solve problems with artificial intelligence and all of the existing technologies couldn't solve your problem, you ultimately found your way to Steve and Mike. This is a quantum computer, and when the team that was building the hardware needed AI that would calibrate the qubits and everything in the world wasn't able to do it, you ultimately found your way to Steve and Mike, and they helped you to develop a machine learning system that would calibrate your qubits. It's fascinating work, but it's really inspired them to understand that some of the biggest gaps in the world today could be closed if we could get these technologies in the hands of more people so that more people could use AI throughout their daily life. And I come to this space from augmented reality, actually. I've worked in the field for over a decade. And when I think about augmented reality, I think about augmenting people. It's never really about the technology. It's about using the technology to empower people. In fact, in my own personal life, I've been obsessed with trying to help people overcome the limits in their own life. Limits like the idea of what you could accomplish in your career, in your work, what you could do, what people expect of you. In fact, that's one of the things that I love about augmented reality. The idea that you can learn things faster than you could with any other technology, any other method of learning, and you could put those skills to work immediately. This crowd, more than any, knows that you can put on an augmented reality device, you can learn a new skill while you're doing it with a lower error rate and doing it faster, and that's really important because this method of learning, this method of expectations and limits that we put onto people is archaic and ineffective, and it's really even more problematic than that because as ineffective as it is, it's also not accessible because there's 7 billion people in this world today, and if you were to take a graphic representation of these 100 people, only about 7 of them would have access to higher education at all. To begin with, that's a pretty bad statistics, and if you really consider what that looks like a tremendous amount of wasted potential of people that just are not empowered to make a difference in this world. And now, here's the thing. I spent over a decade in augmented reality trying to empower people with these technologies. And this was the enemy, the idea that these systems were moving so quickly, they were displacing jobs, they were actually going to be a detriment to society. And when you think about artificial intelligence, this was the enemy, this is what was coming to take our jobs, to take our way of life, and it turned out that that wasn't the case, though that's still the image that a lot of people have today. And I want to talk about how that's not the case. And what I learned and what brought me there was about 7 months ago, I met Steve and Mike, and these are the words that they said to me. And I'll say them verbatim because they still get me really excited about what their vision for artificial intelligence was. And they said that we have a deep understanding of the impact that these technologies will have in the world. And we believe that we have a responsibility to empower people directly in order for it to benefit humanity. And that's critical. But they said this, they said we make AI that is scientifically principled, algorithms that are honest and humble. And who talks about that? Who talks about AI in a way that it's honest and humble? But that is at the core of what we have to build into these technologies to really make them benefit people. They think that if you build the AI from these principles, they can become a reliable and accountable member of your team. And they said to me, they said, it's not about the technology, it's about augmenting people. And these were their words. And it's why I knew I needed to become a part of this. I needed to help them in that journey. And I'll tell you one more story that if you're in the AI space, you probably know. But from the outside in, it was really fascinating. The first part of it is this. We all know that AI beat Grandmaster at chess. That's pretty straightforward. Probably not a big impact, especially if you're not a Grandmaster, because computers have been beating most of us at chess all of our lives. But when you think about it, at first glance, you might think that that sport would disappear, that the idea of competing at chess, why would you do it if the machines could beat humans? Now, it's still fun, so people still do it. However, what's most interesting to me is that the victory actually created an entirely new industry, a new sport called hybrid chess. And in this freestyle league, you could not only have a team of humans or a team of AI, you could have a hybrid team of humans and AI working together. And it turns out over 70% of the time, the hybrid teams win. Spoiler alert, the human teams only never win, but the AI doesn't win the majority of the time. And that's just a really amazing metaphor for how when we team up with these systems, we can actually do much more together. And there's a story within a story here that if you take a high school aged chess champion and pair them with an AI, they can defeat a Grandmaster level competitor, someone that would be decades ahead of their skill level. They can surpass by teaming with the technology. And that's really exciting to me and to us and how we build things. And now, to bring it back to convergence for a second, when you think about augmented reality today, how is that going to shape up? How is that going to develop? How is that going to move from what people use it for today, not the insiders, not the people at the cutting edge, not the people that are using an industry where we've already seen the development, but people in their daily lives. They are already using it to play games and bringing these technologies into their world. And we'll see more of that. We'll see more of it in education and the devices that are growing and changing their capabilities to do more. And it'll unlock new ways to interact with the technology that we already use in a subtle but important way as it changes the relationship that we have with hardware, as it changes the relationship we have with spaces. And that's really interesting if you can have the interactivity and the understanding of the connection between the space that you're in and the digital assets, the digital interactions that you want to have. It can actually unlock a lot of power from that context, from that converged context. A very simple application. How many people have been in line at a coffee shop before? All right, it's an early morning, but it's all of us. Everyone's been in line. But in a situation like this, you have several different levels of context, and it can really help us understand at a micro scale what the macro opportunity here is for the convergence and for the interaction of these contexts. Because if I'm in line at the coffee shop, it's not just that I'm in line. If I'm in the back of the line and I haven't ordered yet, I have my device, it knows me, I should have a menu. That's a specific context. But once that order has been placed, once I've moved forward, I may actually have a different context where it's more about consuming content to remove the stigma of the wait, right? So that context has changed. And then when I get to the front, I'm going to make a payment. And that's really interesting because when you look at moving outdoors, those contexts change on a much more rapid and frequent basis. And you'll learn a little bit more about this today. This is a little bit of a sneak peek of what Nick will talk about later in an open world convergence project that's going to talk about a containerization of these different contexts and how you can interact with them. And now, let's put that aside for a second because I want to talk about how these changes, though, are happening at a generational level. And I see a lot of familiar faces when I come to AWE, people who have been in the business for a long time, and they understand that this happens across decades. And so entirely new generations of people are growing up with new pieces of the technology. Kids have now had Pokemon Go for years, and it will affect how they think about other AR that they encounter in the future. And that's really important. I think a really good way to think about that effect is to look at video games and to look at one of my least favorite examples of design, but one of the most amazing creative tools because it's so simple. The constraints that Minecraft puts on the player actually sets free their ability to create because the system is so simple. And you take this thing that's such a primitive limitation of design, and that limitation then sets you free to create amazing things within that system because you can unlock a different type of creativity. If the minutia was a limiting factor in the creation, creators now in these other systems can express the creativity in a bigger way because they don't have that limit in place. And why is this important? Why is that important? Because this game itself has led to a lot of what we see happening today in digital media and in user preferences. And I'll back that up with a couple more stories, but I think that that type of creation has been spawned by this generation that has spent time inside of these environments. This is another one where people are making entire cities in Minecraft, not even constrained to the aesthetic and the theming, the ideas of the original game, but they're using it as a creation engine to make amazing virtual worlds. And that's exciting. That's exciting because it's taught an entire generation to create in 3 dimensions. Now, let's talk again about a different phenomenon, and that's Fortnite. And now, this is a battle royale style game, and oftentimes its success is attributed to the fact that it is a battle royale game. 100 people go in, and you have one winner in the end. But the truth is, when that genre was emerging, there were many battle royale games that came out at the same time. And so people looked at things like the character creator, where they monetize extensively, as one of the reasons for the adoption. But I would actually make the argument that it's in the underlying gameplay itself where the preference and the familiarity made it take off, and that is the fact that the Minecraft generation that had been playing in the previous decade was now at the age of first-person shooters, and this first-person shooter included both a mining and in fact, not only do they not exist, these are the only 3 samples of these pictures in reality. This is from a project where you can go to a web page, these people do not exist, and you can get a face. It was generated by a GAN, which is a generative adversarial neural network. And that face, that picture of that face will be the only time it ever exists. And once you leave the page, it's gone forever. So these people don't exist. These are perfectly acceptable faces for our own neural networks that were generated on the fly, but they do not exist. The backgrounds that they were in do not exist. And that's really interesting. In fact, that's inspiring. When we think about generative content, though, we think about things like deepfakes, right? And this is where people think about the dystopia. They think about the worst case scenario. What if an end user can make a celebrity or political figure say things that they didn't say? How disastrous could that be for our baseline, our ground truth of truth? But what if it could do amazing things too? What if it could do better things than that, right? Because this will happen. This is something we have to learn about as a species. But look at projects like this, which is Everybody Dance, which was a research paper where they used GANs to retarget dance moves. And they would take a sample video of the researchers who had no ability to dance, self-professed, and retarget very sophisticated dance moves from different genres onto those videos and see their bodies move as if they were a professional dancer. That's exciting, and it's in the early stage because we can easily detect that a deep fake has occurred, just like when we look at a deep fake video, something's a little bit off. But the technology is getting better, much like with the face generation, that we can barely detect the subtleties in most situations. And that brings me to one of the next projects that is I think really visually beautiful and exciting, and this is called GoGAN. This was done by NVIDIA, and this is also using generative networks, and this is where people can create very sophisticated imagery by doing very simple content generation techniques. And that's very important because the level of sophistication on the right is limited to a small number of people in the world. Unless you're taking a photo, to be able to create photorealistic environments is challenging. And in fact, it's so challenging, it becomes a barrier to entry where we don't create in those spaces. We only create with other tools because we can't do that skill. But what if you could remove that barrier and allow anyone to create photorealistic content? That's very exciting. And the samples, there's one more here, where you can work in the space of very simple palettes and then see your vision realized in real time on the other side in this generative modeling, where AI is helping with the creative process, helping people that may have only been comfortable with more simple tools to express themselves in new ways. And that's exciting, and I think that they start to come together. They come together, again, with this convergence with what we're doing, especially in the context of this workshop, thinking about how all of these things come together and converge in the future, and hopefully in really interesting ways. One of the earlier speakers mentioned Stadia. This is actually a generative tool built into the Stadia framework where you can take a sample image in the lower left, and it will apply it to the textures to a 3D game environment in real time, so that you can test out the look and feel of a game during the design process without actually having to create any of the assets. You could test it with assets from your mood board just to see what that feel is going to look like when you're actually moving in 3D environments. And that's really interesting because it's unlocking a way to look at the worlds that you're building holistically with a tool that's more simplistic and a workflow that even the independent creator can start to adopt. Things that would previously require a team available to the individual. And I think that's the recurring theme amongst all these things, is the tools that are have previously been prohibitive being available to individual creators. And now, you've probably all seen this before by now, but is this real or is it synthetic? I wouldn't be asking the question if it wasn't synthetic up here. But it is striking how powerful the new 3D environments and the game engines are today and what's possible within them. And this is all done in real time. This isn't pre-rendered. This is the quality of studio production value just a few years ago, available in real time on commodity computer hardware. And I think that's a critical part of the creative process evolving and moving high quality production value to the individual as well. And AI plays a key part in that, and in understanding the pipelines and automating the parts that have been so challenging in the past, and then optimizing these pipelines to work. I'll show one more example because sometimes people say, well, that was outdoors and everyone knows that outdoors is so easy to cheat on because the landscapes are so amazing. Is this real or not? The camera work is enough to let you realize that it's not, but look at the quality of the textures and the colors and the shapes, and this is, again, none of this is pre-rendered. This is all real-time in the Unreal 4 engine. And that's really fascinating because now you have, again, studio production quality rendering available to individual creators with commodity hardware. So what does this mean? How do we roll all of these crazy things that I put together into a vision of the future where maybe deep fakes aren't just a bad thing? Maybe the idea that individuals can create could change the future. And now I don't have a video of what the future is going to look like, but I have one that's really interesting to me. And it is a combination of digital tools that certainly include machine learning techniques, but it would be unfair of me to show it without saying that a lot of love and handwork went into this. If you haven't seen it before, this is a video from Star Wars, which is a pretty popular movie. And this scene in particular was somewhat anticlimactic, especially when you think about all of the versions of the movie that came later. And there was a team of people that thought this should be different. What would it look like if it was remade today? And this was not made by a studio, this was made by fans. And they thought that the action sequences should be much better and that they should be able to use tools to reimagine a scene like this. If you haven't seen it, it's amazing. It's by a team they called Fix It and Post. This is called Scene 38. Go see it. Again, this was not made entirely by AI, even though they use tools that include machine learning techniques. A lot of handwork and love was put into it. But this leads to the question of what if in the future the individual creators, without the barrier of the handmade content and the workflows that were a barrier to be able to do this, what if people could look at a movie, a studio quality movie, and make an ending that they wanted to see with a creative pipeline that was accessible to the individual creator? Hey Siri, I'd like to see the end of that movie, but this time I don't want that character to die. That's the future of creativity. That's what AI is going to empower people to do, and that is what's exciting about convergence, and that is what is the good that can come out of all of these things, and it's a world that I'm excited for. So thank you all for coming.
Thank you. So these are way too many slides, and this is something like, 20 minutes only, so we'll try to make it a roller coaster ride and, just pause a little bit at what, some of the core interesting things are. Probably if you're mostly coming from, the application side, this is going to be way below your line of sight, what, would like to see happening in the network. And us is a small team in Santa Clara that kind of, been around doing networking, for 20, 30 years. And so we've kind of moved from doing day-to-day development, architecture, customer support into more like a researchy role, trying to focus on the longer-term future of networks, given how the industry at the network level has really very often, seen to come to a standstill. So, and obviously, networks are not good for anything but, really run applications. So everything starts with the application, and we've been sitting around and saying, okay, so what's going to be the, most challenging application for the network in 2035? And, as crazy as it sounded, we came up with holography, right? Because it has a lot of the qualities that existing, and evolving media like AR, VR has, but it's also, having a lot more interesting properties, not only limited to bandwidth and latency requirements, but also to the type of interaction it supports. That's where we came up with trying to position, holography as a potential candidate for communications in the future. And there is a nice, space of how to, get the range between real environments, virtual environments from Milgram and Kishono. The reference is at the end of the presentation. And one of the interesting things is that holography is really the one potential future type of communication that will, allow to come as close to a real environment and, a human interaction as we can imagine right now. And it's not really us imagining it, because, Hollywood has been imagining that for the last 20, 30 years at least, and, shown all type of variations of that, and some of them are really, very enticing. So when we bring it down to earth and think about what could happen, right? So what was the last step of immersive communications that we had before, AR, VR came up, which is still, trying to find its place safely in all these different business cases? Well, it was telepresence, right? So how about holopresence, right? You've got a room full of people, and one participant is meant to be there in a holographic presence. Everything else in the room is real. So now we can start thinking about how much communication bandwidth would this require, what type of interaction would be possible, and that isn't that difficult. But if you turn it around and you see it from the perspective of Alice, who, lovely would like to have the whole room being a holographic representation, now it turns around being a lot more, right? So maybe in the first place instance, Alice may be doing a presentation as a hologram, and holo projectors have been around for 7, 8 years now. I think that's the first time that I saw them demonstrated. Right, you can rent them and then basically do some demos with them, but their qualities are still very limited. No, but if we're basically back at Alice, she might need to get 10 times the amount of data to represent the rest of the meeting room and the people in it as a holographic display. And so the counter down there is still at 0. That means I have infinite time. That's excellent. Right, so what is holographic imaging, right? So it's going to be new ways of encoding holographic information captured from multiple cameras. People today talk about the light field model, which is really a 3D representation of the illuminated pixel representing the hologram. Compression, all the usual things, and there is a wide range of predictions about how much bandwidth this requires, and that of course is very much depending on the amount of compression and how it's going to be compressed. So the ultimate outcome in 10 to 15 years is quite impossible to predict today. But what is really clear is that one of the key problems, if you go beyond a simple streaming experience with arbitrary latency that is just unidirectional, the latency in both directions is obviously of key interest, and that's where the encoding and decoding typically needs to do a lot of compromises. Either you get really good compression quality or you get low latency. If you want to do both of it, you need to invest a lot more compute. And that brings us really down to the network layer when we're looking at the key metrics in the network that we want to drive forward and improve for Network 2030 and beyond. Throughput and latency are the two key metrics there. Loss is the third one. That's a lot more hidden from most people, but equally important, just not that much time to talk about it. And then we're starting to ask ourselves the question, how do we mapping the application, right? So is it about resolution? No, ultimately it's about the quality of the image. And then, the interaction determines what latency I need. And then there are even, theoretical and practical limitations. And so to understand, the following slide, let's just look back a little bit how wonderful, or as we would say, crappy current internet technologies are. And that really is, the internet provides what is called the best effort service. I call it the lousy effort service, but it really means, you get whatever bandwidth is available and you get whatever latency is available. And we started even with applications being really bad with managing latency. Then we fiddled around a little bit. We called that buffer bloat. Within 10 years, we got latency somewhat heuristically smaller, and we're all so proud of it, but it really is nothing that you could really rely on to give you, predictable deterministic behavior. So there is no throughput, there is no priority guarantee, there's no latency guarantee, and also the loss is, quite unpredictable, right? There are cool things done, like traffic engineering, you might have heard of that, and all these wonderful technologies supporting that. But quite frankly, they're not there to make your individual traffic flow better. They're just there to get more out of the network of the provider. So they're for so-called capacity engineering, right? It's more like okay, you're in Munich, instead of just having a few streets congested, we're now having all streets congested, so we're getting best leverage out of, you know, the whole street system, but the experience for the individual driver has just minutely improved. And there has been in the last 30 years a lot of, you know, services using TCP/IP networks that have a lot better varied, interesting service things, but they have really not trickled into the generally available services. They're very much in private networks if you buy a type of VPN service also. So these things are really, you know, still in need of being translated into the ubiquitous availability that is what, you know, we expect from internet services. Let's see. So one of the key things to start talking between applications, which hopefully you're representing, and, you know, what we need to do in the network is really understanding what in the industry is called a mean opinion score, where you put, you know, users in front of an experience, call it video, call it, you know, gaming, call it AR, VR, holography, and you're trying to figure out, you know, what is the quality. And you now insert all type of changes in the application, see how the perceived quality goes up and down. And what we, from the network side, of course, are very much interested in is, well, let's compare the quality of any particular scenario where you're doing whatever you want in the application, the encoding and all these things that have nothing to do with the network. And now we insert some of the problems networks can have, and we would like to understand which of these problems leads to what deterioration in quality of the experience. That's the ultimate thing. We went through this a lot with audio in the 70s, 80s, and with video actually in the 2000s when streaming video started to happen. And, you know, a lot of people were surprised of the outcomes because they all came with the pre-perceived notions that video is the same as audio because we've done audio before, so it must be the same, and was a rude wake-up when it wasn't. And I bet you very much that, you know, with AR, VR, the same thing happens. AR, VR is exactly the same as video because we've done video, we know everything. So, I mean, that's at least, you know, from people who are coming as the Me Too, adopting, you know, new technology without even starting to try to understand it. And so I've listed a lot of, you know, these crucial interactions between quality and the possible things that may happen in the network, right? So, okay, if the bandwidth goes down, your quality will typically deteriorate, but it doesn't have to be linear. If you have some form of interruptions, you have outages, you know, how bad are they to you just randomly losing packets and you get, you know, bad video perceives? And then, you know, if, you know, your bandwidth changes, right? How hard is it for, you know, users to accept that, you know, the quality is changing, right? So it's kind of like, you know, going through the rain. Sometimes you see something, sometimes you don't. So these are all things that we've gone through with video, and we've come up, you know, with some good MOS scores on that. But, you know, even for things like AR, VR, or 360 video, I was listening to a presentation yesterday from a professor in New York. He said there are no good MOS scores for AR, VR, for example, right? So, I mean, that would be a good starting point to have the conversation even shorter term between networking and AR, VR to come up with those and then map them to the network behavior. So throughput. The trouble with throughput is we don't even know what fair is and if we want it, right? So the current understanding in the internet, in the networking industry is that, well, fair means every flow gets the same bandwidth. And obviously that's a great experience if, you know, one person has a movie on a watch and the other one has it on a large screen television. So obviously that is not going to be the same quality of experience. So question, is that fair? Well, even if that was fair, how could we change that insofar as that, you know, whoever wants to have more bandwidth could pay more for it and get more? That doesn't exist in normal internet services. And then even if you think you want to have fairness, we can't do it, right? We basically have problems achieving fairness when the path length is different. So somebody sitting closer to the server gets a better experience than somebody further away. And there are, you know, by now maybe 30 different protocols trying to solve this all differently, so they can't interact in the network. We also have limitations, you know, of theoretical nature. So if basically the network becomes faster and faster, we're going to see it's going to be harder and harder for, you know, the actual transport services in the network to keep up with the speed. And, you know, there are no guarantees. So those are all the issues that, you know, have a lot of research solutions, but really very little convergence of what the industry at large would want to do about them in the internet of, you know, 10 years from now. The cool thing that's happening is that we're getting something that most people will know under, Metro Edge Computing Center, and that is really, driven by, well, web browsing, streaming video, that big data centers happen to pop up in every, major neighborhood. Call it a metropolitan area of, 10 million or more people will have data centers. And when in the past, 10, 20 years ago, you were doing some application that was hosted on the other side of the planet, today, really most of your application traffic will be served locally by one of those data centers within, your metropolitan area. And that's at least saying to us that, A, the speed of light is going to be less of a challenge because we're going to have network latencies of, let's say, one of those target numbers is 7 millisecond, leaving enough, latency for encoding, decoding, all the things that the application is eating up latency with. And then also it means that it's today a lot easier to scale the compute that may be needed to create, these immersive experience, AR, VR, holography in the future, than if you were to have to do it remotely. It's not only the compute itself, but it's of course also the cost of using a network over a much shorter distance. It's much less cost intensive. So, and also, most of these networks will come from one provider, so the, monetization of these networks will become a lot easier and hopefully very much allowing us to go into differentiated services. But now we're looking into what would those differentiations be. Deterministic is one thing that you may have heard primarily coming right now out of Industry 4.0 in Germany, and also a bunch of other use cases that are very much trying to move their existing application experience into TCP/IP network. Well, our answer is, we should, start doing that, but we should also think beyond that, and that's, one of the first three things that we have been thinking about in the network. And we call that high precision communication. And that really means that when you're sending a packet into the network, on the packet alone, you would be able to indicate, what latency budget it has, right? It should arrive, not later than a particular maximum latency end to end, but it may also not need to arrive any earlier. And what this, very, initially illogically sounding thing of, it doesn't need to arrive any earlier than this gives, is that in the network we can now try to create fairness by saying, well, you would actually arrive earlier, but there's some more urgent packets, so I can, preferentially treat them. You will still arrive in the time that you need, but because you also told me you don't need to be too early, I can prefer other packets, right? And that should hopefully allow us to provide a lot more latency-sensitive traffic in a much more dynamic way, much more scalable, and without the need of a lot of the overhead that past solutions have, specifically also in a way that it dynamically adjusts bandwidth but guarantees latency. So this is one of those, very high-level, long-term research project that we have. We've done some initial assessments, but getting this into high-speed metropolitan area networks is, of course, a quite long challenge. And from there on, it gets more interesting. The other thing is most of the interesting communication are just not point-to-point between two people, but they're group communications, right? On the left-hand side, obviously, again, the wonderful 2030 vision of let's have, a holography soccer game. But obviously, these problems of kind of fairness with respect to latency already exist today. When I was, managing my university network in the 90s, the first time I brought up another network, and some of the players in Doom had a slight larger latency of, I think, was 5 millisecond longer. The next day, they stood in front of my office and said, what did you do with the network, Turles? And it hasn't gotten much better ever since, right? So the best thing that networks today have is you try, for whatever network connection you have, to make the connection latency as short as possible, but never do things like fairness. And that's, of course, one of those things that the whole, high-speed trading industry is riding on, that you're getting yourself an unfair advantage by having, shorter latency to the exchange than others, and actually, skimming off margins from them. Read the news and that stuff. There's just, New York Stock Exchange is trying to repeat that experience, and they're going to face a lot of lawsuits against that. And even in gaming, right? I mean, I could basically fake a long round-trip time to get myself virtually a shorter latency. So if the network was in control of saying, okay, all the participants here, however where they are in the network, are getting the same, latency experience, you can create fairness. Another one, coordinated communication, would be to assign aggregated bandwidth to an application. However, the application splits it up between the participants. The network doesn't care, but you may be paying for the aggregate bandwidth. That also has been a typical requirement in group telepresence, and networks have been very bad on delivering that. And finally, of course, coordinated communication has also other technologies to create better scale. The historic one that I think is known from live streaming TV is of course multicast, replication of traffic in the network. One of the still highly challenging problem is in distributed application, the Hadoop incast problem, where you have the problem of scaling server clusters so that you can basically scale the whole application. So, and we call that network support for those things incast, because it's really the opposite of multicast or outcast. Finally, the third part of qualitative communication is really to express to the network what the media you're carrying is signifying as quality, right? So if you've been around video encoding, you'll probably know the scalable video codec from the MPEG consortium, which is a layered scalable codec where you can add multiple different resolutions together. And that, of course, would mean that if you now expose this to the network, you could figure out that if you have a traffic flow that says, I have such a great quality, well, and that quality is a lot more than the quality of other traffic flows that are competing within the network, well, you could pick out these flows and say, can you please slow down? You're basically getting a lot more than what the competing traffic would get. So congestion control, discarding right network actions based on the network being aware and able to react directly to the quality. Today, these things all exist in research, in prototypes, in some limited type of networks. They're not existing in the real internet. And they're all existing on the level of packets, right? So you look at packets in the network. And one of the cool ideas that we're thinking about is also to make this happen within a single packet, which sounds counterintuitive, because why can't you just use packets? Well, because the problem is we're getting faster and faster, and the next generation of networks, for example, could purely be optically switched. And we have already seen in the last decades that we can increase the bit rate of traffic much easier at much lower cost than the total number of packets we can send. So there is a good prediction that the size of packets needs to increase to keep up with the speed of networks, and at that point in time, we would need to look into putting all this intelligence from the application about different levels of quality into single packets, and then make decisions based on that. And there are already interesting research experiments like, oh, you have too much, we're cutting off the end of your packet before we're sending it on, because that was just the part that has the highest quality that basically, would be unfair for you to take bandwidth away from others. So those were basically these three, big research areas we're looking into to increase the service quality in the network. You can bring them all together. And that's what we've been trying to show here, holographic streaming. I'll have to go through the rest of the slides a little bit faster here. So really, the problem is this is a 10 plus year effort. It needs to be comprehensive. It needs to be in collaboration with the application people. We've tried to read ourselves up on AR, VR, and on holography, but obviously we're not the experts. We're the experts on the networking side. And so that's basically I think, the biggest challenge, to bring all the right players together. We think we've got some starting, offer to make what the network could provide if we figure out, how to exactly integrate it with applications and then see the business need for it. A little bit, even further out, people have been talking to go beyond the senses that we're capturing today. Touch, taste, smell. So the overall immersive experience, these things may not add a lot up to network bandwidth, but on the application side, there seems to be at least a lot of research interest. When that will hit, the industry, really, we're not sure, but definitely it's very interesting to read up on the cool, sensors and actors that basically allow you to measure these senses and then also to reproduce them remotely. So where are we? Are we ready for Network 2030? We think from the network side, certainly not. On the left-hand side, you see all these, challenges that we have coming both from the infrastructure and the application side. And on the right-hand side, a little bit, nasty, cynical view from myself about all these technologies that we've worked on in the past 20 years, where we patting ourselves on the shoulder how much we've achieved, but in reality, it's really been quite meager what, the network has done. Granted, it has, provided, a lot of speed, at good price points, but that's where it basically stops, right? Application differentiation, enabling more than really over-the-top, entertainment services of quite varying quality is very difficult, and, I'll let you read up yourself on, the vetting of these core technologies that are listed there, and, how much I think they score. So, here's the summary, right? So on top of the pyramid, obviously, are the new media, the new applications that are going to drive the evolution, both from the volume, the speeds that are needed, but also from the services. So a Network 2030 would basically have two really important complementary aspects. The one are these new infrastructures that are evolving, like, the metropolitan networks with a lot of local compute, with a lot of higher speed, and the ability to better differentiate services. But there are, of course, also a lot of interesting research talks about 6G, mobile access, terabit radio, the emergence of satellite networks, converging them, and of course there are kind of, even in the infrastructure, problems with fidelity, federations. And then, of course, on the left-hand side, the new services. Those were the things that we talked about in the slides. Right, summary, what are the network capabilities? I talked about these three: high precision communication, qualitative services, coordinated services, and then, the collaboration with these four new network-friendly media formats, which is basically the type of encodings, the type of representation we would need to have for better AR, VR streaming, and ultimately holography. And then, maybe when all that is done, the additional senses to make the experiences even more immersive will get into the applications as well. So that was the presentation. This is basically a summary for your reference if you're interested about the publications that we've done already in the past 2 years about many of the aspects here. And as I said, holography, we're not the experts. This has basically been our reading list from which we learned what we've been trying to use in reference to that type of media, and they're really cool reads. And that's it. Our email addresses are there if you want to contact us, and thank you very much. If there are any questions.
So I'll start off with a question and then open it up to the audience. So I guess I'm always interested in what has been the change that you've noticed over the last 12 months in the development of these technologies that's most affected the work that you're doing? And who wants to start off with that?
Well, coming from, is that? Yeah, I think it works. Coming from the network side, I think the major change for us is that we're seeing, increasing interest in the industry to, at the network layer, think about the longer term work, and that's primarily by, creating, meetings, and we've got now a focus group in the ITU standards body, which is actually what I'm coming from in Geneva, and so that's basically one of those where we can at least start describing, the missing standardization pieces we see long-term from the perspective of what they should achieve, not what they should really be. And so, well hopefully that can help to start the discussion a lot better than, it could be just through, well, what's been done mostly now is, a lot of isolated research projects, right? So kind of pre-staging possible future standardization and interactions with industry.
I think basically that in my field of augmented reality, at least, that especially in the enterprise sector, people are moving away from these cool-looking, gimmicky stuff and really are focusing very hard on use cases that really bring return on investment. That really has changed. And the experiments in the past that were maybe done in 2018, 2017 or earlier kind of disappointed many enterprises. So we experience that when we speak to enterprises, they say like, hey, we tried this out, we tried this out. We were so enthusiastic about it, but it didn't actually work. And this is a huge disappointment that kind of is annoying us right now because we have to go in with a cheaper price point initially. but the experience was definitely burned by enterprise in many scenarios before because the stuff were over-promised. So I believe now the enterprises are sort of more woke in the sense that they really want to solve the problems, but also are a little bit more cautious. But that's a good thing, I think.
So I mentioned during my presentation already a bit, but I feel like collaboration is really becoming something that's expected on the web and in all kinds of applications, where, like I said in the beginning, there were only a few big companies who could really afford to roll their own infrastructure, whereas now it's becoming so prevalent across diverse apps, both for consumers as well as professionals, that I think users are starting to expect collaboration as just something that every app has to have, and not just collaboration, but real-time collaboration where you look at a shared thing. And I think one of the most interesting developments there will be the kind of user interface paradigms and expectations that we will have to collectively come up with, kind of in the same sense that all the different operating systems had to invent common ways to do things. Now we have to invent how to do things collaboratively, what the expectations are on content if you work on it together, especially if you factor in things like latency. And also how, yeah, never mind. So how will we deal with collaboration in a way that works similar across different apps, and what are the new expectations and behavioral patterns that we will see there from users?
Cool, thanks. And then a sort of follow-up to that is, if you are going to predict 5 years into the future, you're still working on the projects you're working on. What's the thing that you say, oh, that's when it gets really cool when I have this? What does that unlock for you? 5 years.
How about the other way around first?
Sure.
I mean, in my first answer, I kind of started already going into the where is it developing. I would love to see for collaboration to become so prevalent that it's almost not just that you expect that you can do it, but that you expect that whatever kind of content you're creating or whatever kind of game that you're playing, that it will for sure be collaborative, and even remote work will feel much more like this shared by default experience.
So in our case, it's pretty simple. Basically, two things. Cheaper augmented reality glasses, which I believe will be prevalent in 5 years' time. In enterprise, the price point has to come down to under 1,000. It has to be light. So those are the two requirements that we learned. In the consumer space, of course, it has to be much cheaper. But those 2 points, I mean, the AR glasses point definitely will enable us to grow very heavily, and the connectivity, so the prevalence of 5G. So the 5G, the AR glasses, I think in 5 years we're going to be there where it's going to be totally prevalent, and then, at least in our perspective, we can really scale. Yeah.
Yeah, so I gave the microphone back because I was actually trying to figure out whom is he asking. And, you know, there are at least two people here. You know, one is my paycheck and one is me personally. And so I think the paycheck obviously would love to see, you know, progress being made in the industry through the standards body starting to work, you know, more on the longer term things. We're trying to drive them through. Personally, I'm an avid user of these technology early adopters. So I like to see really cool new applications emerging in AR, VR that, I'd love to use myself. So maybe the intersection of this is really, the work that we're starting to do with some universities to set up these demos, right, where we basically have, for example, AR, VR, even though it's far away from the holography, right? So, but what was it? Holography projector was something like 20,000 to rent for a day or so, last time I asked. So, so demo with these applications, and then the network in there and showing, what difference the network would do, right? So I think the demo is that what both makes me, I'm motivated by the applications, right? But then also, the possible customers, I think demos are always the best way to go forward, moving research into the industry. Yeah.
Thanks. Does anybody in the audience have some questions that they want to ask the panel? Yeah, in the back.
So I think there are two data points, right? So I mean, we've been scraping around on AI, net intelligence. Even in the standards body, we had a year or so where we tried to bring people together, but within the network proper, it's quite difficult. And I think there's the one layer where it is already making progress, and that's basically in the network management level, where you're trying to, organize the network, trying to work out policies, figuring out if the network is well working or not. One of the interesting answers from somebody, when I asked the same question to somebody at Google, was that they're actually, fairly happy with a lot of these deterministic, not AI mechanisms. But when something goes wrong, they typically have to solve this today with human intuition. And so one of the things they're trying to get out of AI is a little bit more intuition, right? That's, of course, also very aspirational, right? Most of the people that use AI are just using it because working out, more explicit algorithms is a lot harder than trying to let the neural network learn itself, right? So it's easing the development process, right? It doesn't necessarily create other outputs or other results. It just allows you to create them easier and hopefully with less compute. For the things that, my team is working on, you saw it's all about, gigabits, terabits of data. So what was it? So last week we had a good discussion in the office with our AI expert, and finally we came out of the point of this would all be great, but the speeds you're talking about, Turles, are just way beyond what neural networks today would be able to afford. And neural networks are being put into all places, right? I mean, in Huawei they had the first neural network chips, I think beginning of last year in 2018, right? And from that point on, you start learning of performance, because one of the first things was the first generation of the CPU was just faster, slower than the CPU itself, right? So basically from concept over to the industrialization, I think now we're in these steps in our equipment, and we're trying to figure out what the cool things are we can start doing with them in network equipment.
Kind of along the lines of this question regarding how what's going on in networks is being communicated, I feel there's a bit of a danger of like edge networks and edge computing being like just the next buzzword, where like after cloud comes edge. But it's actually something that, like the cloud, is qualitatively different, and I think where everyone involved in the whole stack really needs to reconsider their approaches, and using demos or whatever else is possible, we have to figure out what does this really enable and what does it really change, and where is it maybe not the appropriate solution, or where will it be hard to adapt before everyone just jumps onto the bandwagon.
Just to touch off your feedback that you gave, I think in terms of local computing, so be it edge computing or a similar nomenclature, I think that is going to be an enabler for not only our sectors in terms of collaboration, AR, but basically entire application systems or operating systems that are going to be put onto that. I think it's really, it's just a matter of coverage, right? If we're 90%, 99%, 99.9, it really has to reach this 99.99 for it actually to make sense, and then you can really switch over to a total system that is completely dependent on it. I think that will come, and the benefits will definitely outweigh the bad parts. So I think really it's going to happen.
Any other questions from the audience out there? Well, while you guys are thinking about that, I'll do another one. Oh, there.
So the $1,000 number is what I got from the industry in the German, industrial sectors, right? We're talking about Siemens, Trumpf, Daimler. Those are the targets they mentioned that for them. But I think that ties to the amount of applications that they can envision at all, because currently they maybe can't envision other applications that would determine maybe a higher cost point. This is not clear yet. So maybe that's also a good sign actually for the future, that if price will come down even more, then the application and possibilities will also increase, and then we will have this flooding of value that just comes on top of that. But yeah, so 1,000 is what the status is now, what I hear. But it has to be lightweight, so that's very important for them.
Yeah, just as a small addition, it's more like an outsider to the whole enterprise industry AR thing. I think you're exactly right that the price point comes maybe from a lack of imagination of what could be possible, and it's kind of really up to us to show that the possible applications deliver more value than this 1,000.
Yeah, I mean, I think the 1,000 is also the typical, cost factor in large enterprises for a notebook for an employee, right? So what's the most easy number you can come up with? That's something like that, right? If you look at people in the field that are doing specialized tasks in maintenance and other stuff, you don't want to know how many zeros are at the number of the equipment that they need to carry around to do their job, right? If you're having a use case that's even starting to replace some of that equipment, maybe also, sorry for the pitching, backhaul some of the complexity of that stuff through the network and just, have the sensoric aspects of that, right? So the numbers that will be accepted for the new user interfaces will go up equivalent to with what was there in before, right? You can even charge higher prices if you create better outcomes, right? Otherwise, well, you have to compete with what there was before.
Any other audience questions? Well, one thing I'm interested in is, since augmented reality and spatial computing is such a rapidly evolving platform, what are some of the shifts that you're noticing this year? AWE hasn't quite kicked off yet, but you can probably start to sense some of these trends. We've already touched on it a little bit. What are some of the shifts that make 2019 different from 2018 or 2017?
I have to admit that I'm not that intimate with the AR VR world, but I think it would have to be what you already mentioned, that we're kind of moving beyond the gimmicky demo phase and starting both, like even on the consumer or the user side, to think about what actually delivers value, what are actually pragmatic use cases for AR and VR, which go beyond we're now also doing AR, VR, but like we're actually solving problems either better or even solving completely new problems with that.
I think an important point is that now enterprises want to intertwine this capability with their internal systems. So that's, and that I think relates to this non-gimmicky gimmicky factor, because if it's gimmicky, if it's a demo, then you don't really want to integrate it into your CMS systems, into your SAP systems. You don't really need that. But now, when we approach customers, they ask us about this, number one, and number two, they immediately ask about the rollout model, which kind of indicates that they don't want to just do it for fun or for marketing purposes, but they actually really want to create value. So those are the changes I've seen here.
Mm-hmm.
Yeah, I've only followed, the whole application equipment side tangentially, but wasn't there kind of the rollouts of things like from Microsoft and others within the last 12 months? I thought it was not, longer ago than that, right? So I think the enablers are starting to build up now, right?
Yeah, so sure, maybe it's from my startup experience. We're not Microsoft yet, but so I think they have like a different reach. But also there, I mean, you have 100,000 devices, I believe, in HoloLens, something like that. So even in terms of rollout, it's still very early. Right. So but just in terms of like maybe non-large corporations, maybe more so on a startup phase, they're thinking about the rollouts, which before they didn't.
Well, I mean, one thing, and I'm also thinking that the whole industrial, medical, whatever these, vertical industries are, I think that's the most exciting one, because ultimately the value that can be gotten out of those technologies is the largest. But that's also just me having worked within, enterprise, industrial, those applications in the past. But the best business model, I think, is still, how is graphics being sold to enterprises? Well, you have this small side business called gaming that basically gets you the large volume to bring down the prices, right? Look at NVIDIA's model of operating, and I think, you know, that's what AR, VR also needs to kind of tackle, right? So I think the consumer market is a great, you know, amplifier of technology, bringing down the prices, and then also having people who have a lot more resistance, right? So if your kids are using this stuff, right, why can't your co-workers use it, right? So I mean, that stuff I think would help a lot.
Relating to that point, I think we're in this phase, if you compare it to Tesla, right? You had this very expensive Roadster, then you had the Model S, and now you have the Model 3, which is cheaper. We're now in this kind of intermediate Model S phase where we have to target this sort of value generating, I mean, more expensive, but still value generating. So the manufacturing sector is that sector where the price, the productivity per square meter is kind of like quite high. So there is the best possible entry right now, but later to go to the more broader market, then the gaming collaboration sector is really going to be where it kicks off. So I really believe that in this sector it's going to be where the big stuff is going to happen, especially on glasses and stuff. But we have to enter where basically we can survive, sustain ourselves, and grow in enterprise first, and then we will move out to you guys. And please make a Unity SDK. I mean, that would be like an ideal fit, seriously. Yeah.
Yeah, obviously, and just to repeat your point, because I think it's really important, you can use games and to a certain degree also kind of vague creative demos, that's at least our experience, where you try to show what's possible in terms also of UI and the kind of content you can create collaboratively in a non-pressure setting where you don't immediately need to make it relevant to your customer's world where they might want to use it, but where you show, like in a game, for example, which kind of Minecraft-like crafting or building mechanics you can have, which then suddenly starts to look like something, like you said, well, my kids can use it, but this is also obviously maps into the kind of professional problems that exist in my industry.
So just a side note of what we wanted to build one day is a game where you have, well, we have some game companies and they would like to have a dragon somewhere in a park or in a large building, and multiple people attack it and shoot stuff. So if we could have this this in Unity, then we would definitely give it to them. And they, based on our mapping and visual mapping, positioning platform, and your technology, would make a really cool AR experience game. So,
well, I think price point and quality differentiation to, you know, get with crappy quality into the lower end market of gaming, and you know that, you know, it could be afforded for kids. I think that's important. Obviously, you know, whenever I look at the quality, I'd love to have more and more. So I hope for the professional products. But yeah, I mean, is there no Pokemon with AR? That's basically what I think what you were mentioning, right? In the past few years, people have been running around with their phones to find the dragon, and now obviously the experience would be so much better with AR, right?
yes, so Pokemon is, of course, as you know, a very local experience. It's sort of not meant to be this kind of persistent thing yet. I mean, it's going to come, etc. But I think this game concept of finding this treasure hunting, I think that was more the selling point, not this AR interactivity, but definitely it's going to move into that. And when that happens, it's going to be really pretty exciting.
Do you guys have any questions for each other? Or any other questions from the audience?
Regarding also the game that you discussed with the dragon, I recently was at Microsoft to look at the HoloLens 2, and the guy from Microsoft also told me that they're rolling out Minecraft now in different cities. How far do you think this scenario of games that you can play everywhere together with spatial anchors that fix stuff, virtual stuff in the real world is away? Like how long do you think that's going to take? Realistically, or is it possible to
Well, I mean, if it's outside, you kind of hope for a mass market adoption, and the HoloLens, you know, we don't run around with HoloLenses yet. So I would also say for that, 4 years, 5 years.
All right. Well, if there aren't any more questions, then we will conclude the morning part of this workshop and break for lunch. Thanks everybody for participating, and we'll see you at 1:30. Thanks. Well, welcome back. Well, welcome back, everybody. I hope you all had a nice lunch. Due to some missed plane connections, the schedule for the rest of the afternoon is going to be a little bit shorter. Lean Seegers, who was going to be giving a talk on Lucid Web, was not able to make it in time. So I'm going to push my talk, Everything Converges When Spatial Computing Goes for a Drive, up now, and you can kind of just imagine the entire schedule for the afternoon being pushed up in that way. So we'll basically end a little bit earlier today. But I think it's like Oktoberfest, so that should be good for everybody. So my talk is on what happens when everything kind of converges in a car. As I've been introduced myself earlier, my name's Nick Sherman. I'm a designer and a storyteller at Important Design. We're a design and consultancy firm in Los Angeles, focused on the power that new realities like AR and VR have to fundamentally transform the most important things that we do in the world. And whenever we start a new project, we always start with a question. What will people do with the future? As designers and artists, this is a critical question to ask. And we don't just mean what will be iteratively different, but rather what will be fundamentally different because of the convergence of new paradigms, spatial computing, artificial intelligence, 5G. And in order to do that, we need to think about how these new paradigms will affect us. How will the human experience of them be the same or different in the future? This is what UX is. Understanding the human experience of your product and technology. And it's good to remember that in everything that we do, because user experience is not about the technology, because technologies will change. And if we're talking about AR, yes, it's very important to be experts in AR, but also it's equally important to be experts in the human experience. Because though technologies will change, what keeps us human is a bit more stable. Here's a good example of that. I love this one because it really gets us thinking about our preconceived notions of things. Perhaps, what do we imagine augmented reality to be? Is this augmented reality? It's a three-dimensional object overlaid in space, but then when we change our perspective a little bit, we see that the technology that was used to create it is just perspective drawing. So what are the current technologies that we have for delivering AR and VR? Most of us are pretty familiar with this field. That's why we're here today. So I won't go into too much detail on it. All right. So for the most part, we see augmented reality taking hold in enterprise and industrial scenarios right now, primarily because that's where the potential for ROI offsets some of the expensive costs traditionally associated with today's expensive AR devices and AR app development timelines. Some of our previous speakers today have hinted upon this. We're trying to get that cost down to below $1,000 and lightweight, factors like this. The truth is today, industrial-grade wearable AR glasses are not cheap, but they can be very effective, and more industry leaders are finding it to be an important area for R&D investment. This chart shows just how big that has the potential to be. And we see within a couple of years' time, possibly $9 billion investment in enterprise and AEC. And at the top, we see a smaller section for consumer AR. And the question on a lot of people's minds at AWE this year is, how do we get to consumer AR? Well, it's going to start at work, which is not bad because many of our greatest inventions have started at work. The wheel, the printing press, the phone. And why will it start at work? Well, primarily because it's effective. Undeniably, it saves us time. It helps us to do things faster, to learn new skills. And how does it do that? Well, this is a good example. This demonstrates how AR can teach you to use, in this sense, this is an invented machine, an invented impossible to operate device that we call an arc reactor. And in it, a user is given AR work instructions, guiding them through the necessary steps to keep it from exploding. So if you can use AR to teach yourself how to operate an impossible to operate device, then you can also use it to learn how to operate just very difficult devices. For example, the wind turbine, the motor in a wind turbine. You can use work instructions to teach you how to service these motors, and beginners can reduce a process that would normally take up to 8 hours of classwork time. With AR, they can complete the same task in 45 minutes. 480 minutes of class time drops down significantly. So how is this possible? We think AR can create a new type of cognitive literacy. What we mean by that is a visual narrative that leads to radical self-understanding. It lets you look at things from every perspective, to learn without language, and to see how everything is connected. And if that's true, then if AR can really do that, then it's clear we're working with a very powerful medium. And as lovers of superhero movies and comics know, with great power comes great responsibility. So this is a quote I like about that. "We shape our buildings, thereafter they shape us." And what I mean by this is when you're building a house, if you're trying to figure out where to put some stairs, if you put a few extra stairs in just the right place, not only will it help you get to where you're going, but you might also find yourself getting in better shape for the rest of your life. But if you put them in the wrong place, you could trip, you could fall down, you could get injured. So when we're talking about building out these new platforms and how to build them, we need to think about not just where are the platforms going, where is the technology going, but also how are they going to shape us. And it was with that in mind that my colleagues and I realized that we needed to develop a new set of principles to help us work with this new medium, the principles of design for augmented reality. The first one we came up with was always begin as if there were no device between you and the experience. Basically, this is a question that we should ask ourselves. Is this thing really a limit? Should this thing hold me back? Because the only limitations that will hold us back are the ones that we're willing to accept. And we can apply that to devices as well. We shouldn't be constrained by thinking about an augmented reality device as just something which a simple Google search brought up. Or an even older version. What if you had to walk around wearing that on your head? Another principle that we came upon is great AR creates something that can't exist any other way. One of my favorite examples of this is actually kind of a throwback. This is kind of an oldie for the AR world. This goes back to 2014, but it's still very relevant and a very powerful example. The idea is that it would teach you about chemistry. And if you're not familiar with chemistry, you know that most of the elements in the periodic table will kill you if you touch them. So this app taught students in the United States and around the world to interact with the elements of the periodic table by projecting AR onto these wooden cubes. And when you combined two different elements together, you could see the compounds that they were creating, and it was really effective. And we thought this was a great example of AR creating something that really couldn't have been done in any other way. Another principle that's particularly dear to me, because I come from the movie industry originally, is that just because it looks good in a movie doesn't mean it's a good idea. So what do I mean by that? Well, working as a writer or a graphics designer or an editor, I was constantly faced with the task of how do I move the story forward, either through a joke or some kind of form of suspense or some dazzling image. And we see that in movies. We see this is Avatar, and there's lots of glowy lines. We don't really know what it means, but it looks really interesting and cool, so it must be important. Here's another example that we're probably all familiar with, Iron Man. And when this movie came out, I knew a lot of AR designers who were actually influenced by this. Not only because it was cool, but it was also exciting. It was seen by a lot of people, so it kind of created a common dialogue. But the problem is, it's good in a movie, it's not good AR. If you were actually in this suit with all this information flying at you, you would become incapacitated with cognitive load, and you wouldn't be able to make a single decision. Here's another one. Probably some cognitive load issues here, but also just if you're actually working with your arms up there, you're going to get a repetitive stress injury very quickly. So good movie, probably not a great user experience for augmented reality. Another principle that we came up with, don't block the keyhole. So what do I mean by this? Well, if we look at this image, this is a car driving on a road. We have an AR HUD. And the keyhole in this is, the keyhole. You look through a keyhole to see something that is beyond your grasp. You don't want somebody to block the keyhole. So in this case, the keyhole is the world. And what we're doing is we're sort of blocking it with the AR. Now, it's a little bit of a trick here because the cars are conveniently spaced just so far that you don't really notice the problem. But what would happen if a sheep or an antelope darted across the road just about where you see all those numbers? Would the AR block it, prevent you from seeing it? Isn't that exactly what the AR is supposed to do, is to make the driving experience safer? So, looks cool, but now that's a good example of blocking the world or blocking the keyhole. Here's another example of that. Videos showing AR HUDs work really well when there's no cars on the road, because the main problem is what happens when there's a pedestrian or somebody right in front of you. How does the AR overcome that? Well, if you don't have any cars on the road, you don't have to worry about that. You can just make it look really awesome. But we were interested in what a better form of presenting AR in a car would look like. So we came up with this concept video that followed the rule of not blocking the keyhole, but also tackled the challenge of beginning to think about what augmented reality might do in the car. In this scenario, we have one of those old-fashioned cars that you still have to drive with your hands and the wheels. So a normal car, you could also say. And in this example, the AR pops up just long enough for you to see what you need to see, and then it disappears. So you receive information, and then you act on it. So what can we do with that? Well, remember when I asked earlier how we get to consumer AR? We can look to mobile for clues on how to get there. All right, so I showed this slide before. So the thing on the right, yes, that's a phone. So how did we go? How did we go from that thing, a thing of work, to a thing to play? Here we see the progression of the phone in multiple stages, but there's actually a missing stage here. The moment when we had it in our car. So why did the phones start in the car? There were a couple of reasons for that. One, it was very expensive to begin with, so the cost could be amortized over the life of the car. You didn't have to pay for it outright. Another technical hurdle that was facing it was the battery life. You couldn't really carry around a huge 10-pound battery, but you could put it in the trunk of a car. So that worked. And third, the cellular networks that were required to make this a useful tool could be built along the highways, which was an easier challenge to tackle instead of just building networks everywhere. So that's why phones started in the car. And we think that AR will follow a similar path towards massive adoption. We think it'll be the first place that you'll really get the AR device that you'll use every day. And we'll continue to see this happening more and more, and it's only going to accelerate as we start getting into driverless cars. And this creates a new experience. With driverless cars, AR, you won't have to worry about blocking the keyhole so much because you don't need to be using your eyes to look out for sheep or antelope or pedestrians crossing in front of you. The car will see that. The main task of the car is to create trust between itself and you, to convey to you that it knows and that it sees all the things that it needs to see. It'll also become a new place for entertainment, for doing work, for learning how to play a musical instrument. Whatever it is, this becomes a new mobile experience that can draw you into your life even more. So we started to think about that, and we wanted to come up with a more practical approach to this, to take it out of the realm of just a high, lofty idea. And we came up with the idea for what we call MOVE as an augmented reality operating layer. So what does that mean? Well, here's kind of a big picture overview. If you imagine an idea that we call containers. So we see these dotted lines surrounding some of these cars. There's sort of a police car in the bottom left of that image, and it's in a container. And then that you can kind of sort of see that that cop is probably looking at the driver's license of somebody. They're having an experience, one kind of an experience, but then there's different containers in the world. They're shown here by different colors. The idea is that we can have these moments of contextualization that we can interact with by entering them, and we can gain an AR experience that can unlock new possibilities for us. Let's say you're on a toll road, a bridge, for example. You're driving around, you're getting your AR navigation instructions just a few feet in front of your car where it feels natural to see them. In this case, we're driving to mom's house. But now you're going to have to pay a toll. Well, what we used to know as the pay station is now a virtual container, a mini app that we can interact with through a handshake agreement between us in the car and the app in the real world. So we get closer to this handshake agreement, a transaction hotspot, and then it opens up. It reveals itself in this case as the Highway Express toll payment app. The idea is that this could be an open source framework so that anybody can easily make their app or experience into a Move container. We define the framework, it's simple yet effective, and everybody can start creating content right away. The way you interact with it is it's powered by your phone. The app asks you, do you want to accept or ignore this Highway Express app? You accept. It opens up, it loads, and it asks for it requests a payment of $2.50. Your phone already has all your payment info in it, so you just select accept and pay, and you've completed the task, you've paid for the toll, a handshake releases, and you keep on driving to your mom's house. If we think about some other use cases, for example, parking at a smart building, how would that look like? We did a persona study for somebody and analyzed her parking habits. Does she like app-based parking? Does she get annoyed when she has to put quarters in a parking meter? Does she prefer monthly pass or ticketed transactions? And we started to use that information to think about how she would interact with the Move experience. So here we have a demo that we built in VR simulating this experience. We see the driver getting AR instructions, the handshake agreement opens up. The app, in this case, it's a little bit hard to read, but City of Windridge Park and Ride. Does she want to accept? She does. Goes forward, and the app engages with her. It's going to cost $10 for her to park here for the whole day. Presumably, she'll take a train someplace else. She accepts, and now it searches for a parking space for her. So she enters the parking lot. It's found there's 3 parking spaces available, number 2, 4, and 5. And with her phone, she can select which one she wants to go to. And this is a driverless car. So she's sitting in the driver's seat, but her hands are not on the wheel. She selects parking spot number 5, and the car goes and parks for her. Then the last step is to take her payment. So after it's parked, it opens up the payment requestment app, confirms her credit card, she selects it, and now she's completed her interaction. Closes it up, thank you, and the handshake closes up. So that's one possible use case for this kind of an interaction in the world using AR and our mobile devices. Let's think of another one. This persona is Luis, and he is, we're thinking about how he likes to interact with a drive-through restaurant. So in this use case, we're imagining a sort of pop-up drive-through. So the typical infrastructure associated with going to a restaurant, a drive-through restaurant, you wouldn't really need that. You don't need a giant menu, because that menu can be served up to you in AR in your car. The point where you would eat could even be multiple restaurants at once. It could be a cloud kitchen that's serving numerous brands, and you get to choose which branded experience you're going to interact with. In this case, it's a coffee shop. User selects what item they want from the menu, and they pay for it, and they get back in line, or the food is delivered to them, all from the ease of your car. Closes up. We think Move will connect people to the future of smart vehicles and the world around them. And here's some more cases that we can begin to imagine that. Think about how much safer a pop-up traffic control system could be with this kind of AR assisting you. Or if you have kids at school, when I go to pick up my kid at school, there's usually a long line of people waiting to pick up their kids, and we all put the name of our kid on a big piece of paper on the front of our car, and somebody sees that kid's name, and then they call in a walkie-talkie, they get the kid comes out, gets in your car. That secure transaction could all be handled much more effectively in this kind of an AR container. Or imagine the way you go to visit a new city when you're on vacation. You won't get lost. You'll find out helpful, fun facts about where you're going and the places you want to explore. Let's think even bigger about it. What if you're at an airport? What if there wasn't a car? So how would it help us check in, pass through security, and get to our gate on time? The possibilities for these kinds of AR container-based experiences we think are endless because they work for us. They come from an understanding of the human experience. And when I started this off, I said that UX is understanding that human experience of your product and of technology. But the truth is, great UX is understanding the human experience of the world. And this is one vision of where we see that heading. So, thanks, everybody. Any questions? As you remember from his morning talk, he's CEO of AI company MindFoundry, and we have Tish Shute,
And I'm
director of AR/VR at FutureWay.
also co-founder of this event.
Exactly, right. Yeah, and they're also, they're both members of AR.org, which is the sort of parent organization that's created this event. So I'm going to hand you the microphone.
Oh. Yes. Well, I mean, just that's sort of the way I think is actually very molded by some of that background. Like 10 years ago, Ori Inbar and I met at ISMAR 2009. Anyone ever been to the ISMAR's in Beijing right now? Anyone been to that conference? It's the big...
Does it count if I raise my hand?
Yes, Brian. It's the big academic conference, and it's very much focused on some of the very hard technical problems of AR, VR, and always has been. And in ISMAR 2009, Ori Inbar and I, and actually Jay Wright from Qualcomm, who was the first sponsor of Augmented World Expo, all met at ISMAR 2009. And the real thing that got us excited was the fact that we now had mobile tracking and the iPhone. And we all three of us thought, well, isn't it time to get this out of academia? And you know, that sort of was the beginning, and most of you have participated, I think, probably in a lot of the history since then. But it's been the last 10 years have really been about solving some very hard technical problems. And I think the vision for the next 10 years is really focused on a couple of things. It's really going to be much more, we have to begin to think very seriously about what we want to do with this technology. I mean, we were so focused, the centerpiece of ISMAR 2009 and previous ISMARs was the tracking and mapping contest. And that was really where you cut your teeth. But now I think we really have to begin to look up and down the full stack of these, this new proposition where we make reality the platform for computing. And I think that's quite challenging as, at the top level of the stack, you have sort of policy and ideas of ethics and trust, and the language of that is very different from the language of engineering, say, which probably most of us are more familiar with. But that's what and also the other obvious trend, and it's very much part of this, is when we began in Augmented World Expo, basically the trend was mobile first, and the trend now is, it's hype too, but it's AI has become the centerpiece of most of these technologies. So, and that's, we're well aware. I should hand over to Brian now, because he gave a wonderful sort of picture of how we need to begin to think about these things differently. So that's where I come from.
And that was a great introduction. I don't know if I'd follow up. I've been coming to the AWEs since they were called ARE. So the first one 10 years ago, and when they got a board, I joined as a board member, and it's just been really exciting to see it grow up as an event, starting in a forum, I think about this size in Santa Clara, and then now to grow and be on, I think 3 continents, and happening 3-4 times a year is really exciting.
Well, so on that note, now that AWE is in its 10th year, what do you think of the changes that you've seen over, talk me through as somebody who's been to all 10, presumably. What are the big changes that you're noticing?
I'll go first. I think that there's a lot of big changes. I think the one that's most interesting, though, and the most impactful is the change from thinking about the technology, like Tish mentioned, to anticipating the needs of people. And I think that the industry has had an identity crisis the whole time, as evidenced by the fact that we've changed what we call ourselves and what we call the industry, I think, every year. Whether it was AR, XR, or and now it's kind of settling on spatial computing. Maybe it'll change, maybe it won't. I think it doesn't matter, right? What matters is what consumers start calling it eventually, and then we need to stop and all call it that, because that's what's going to be helpful when we really identify the fact that it's people and people using it in their daily lives that need to identify what our priorities are versus the technology, which is beautiful. The technology is technologically beautiful, and the fact that we've overcome so many of the challenges to get where we're at and to get the capabilities and the devices is a wonderful thing, but it's not actually what takes us to the next level.
Yeah, it's interesting. People often ask me what are my biggest disappointments of the way sort of AR, VR has evolved in the last decade. And I think, one of the biggest things that we, really we've basically done it's been really exceptional, I think, some of the technical gains we've made. But I think we've had a lot of problems really bringing, the dream of Augmented World Expo, Ori always thinks very big, was 1 billion active users by, I'm not sure, 2020, right? Which actually, it depends how you defined AR, you could actually say there was that. But I think one of the things that really, we haven't really understood is the infrastructure. We've actually got a lot better in understanding the experience, but just because of the way current business models work, we've had a very fragmented community, and in the sense that we have all these sort of different efforts by different companies, and they sort of run very separately. And we haven't been very good in thinking, what are the ways that we can enable this technology jointly, and what are the things that we need to allow to be developed in niche markets and allow, I think that it's, a lot of people want to say the disappointment is, well, we didn't get the glasses yet. Well, actually, I think we were very lucky in the fact that actually other things happened that were almost more important than the glasses. So that isn't my major disappointment. That will happen in its own time. But we made this shift, and I think Brian talked about these shifts in how what we've called AR, VR. And this term spatial computing is actually huge when you really dig into it, because it's really brought in this thinking to AR, VR that takes it beyond personal computing, this idea, I think Magic Leap has a great thing on their idea of what personal computing with glasses would be. Personal spatial computing, they call it. But the real thing that's really different about spatial computing is it's actually not personal. It's really a huge shift away from personal computing. And I think some of the things Brian and Nick talked about shows us how the first definition of AR/VR, I think, was 3D registration in real time and interactive in real time. 3D virtual images, 3D registered in the world and interactive in real time. Now, the definition of spatial computing has included emergent behavior, proactivity, intelligence, and anyone want to give a definition for intelligence? Do you see where we've gone? And these things are beginning to happen as particularly looking at some of the autonomous vehicles use cases, really tells you there were no glasses necessary in the demo you saw from Nick, for example. And I think we really have to start, as a community, wrapping our head around this spatial computing and, what does intelligence mean in our spatial computing? Because this is, we're not going to be very far off when really screenless spatial computing is probably going to be just as important, if not more important, than personal spatial computing with the mythical glasses that will come. But by the way, everyone has said they would arrive 5 years away since 1995. But 5 years eventually happen, so then they suddenly happen, everyone goes, oh.
You're either too early, or too late.
Exactly, you're either too early, or too late.
What do you think are the real barriers to adoption? Would you say it's cost, weight, usability, something else?
All of the above. I think from my perspective, it's really interesting. A lot of it has to do with the problem or the use case and the person and the context, where things like cost are actually transitive. They change, right? If it's if it's in a vehicle, it's a very different cost base. If it's for enterprises, it's a different cost base. I think we heard earlier the idea that enterprise needs it to be less than 1,000. That's a specific type of job role. What we found in the enterprise space was there's different types of workers that have different amount of money invested in them for everything from the equipment they use to the personal protective equipment that's given to them. And that someone working in a warehouse, for them to use AR, it would have to be much less than $1,000 for sure. But somebody who's a field service engineer, completely opposite. They've got hundreds of thousands of dollars in their service truck and the tools and the instruments that they use. And if you can make them a little bit more efficient, they're not actually hardware price sensitive. It actually opens up a bunch of different opportunities. I think with consumers, if the experience, if the value, the joy, the serendipity, the usefulness, the closer we get it to be part of their life, then I think it's much more like a cell phone from an economic standpoint. And you don't have to worry about being an accessory where you might get stuck at 30% of the cell phone price because we don't buy accessories that cost more than 30% of the value of the main thing. Maybe I don't need a cell phone. Maybe the glasses are so important to me that it's a modality. Like I have a cell phone, I have a tablet. And so at that unit economic, I think it's really familiar to people, but still hopefully maintains accessibility. And we get the economies of scale and the competition that's led to more people in the world having cell phones than probably most other types of products that we've had in the past, which is pretty cool.
Yes. In one of my other hat, I'm director of AR/VR at FutureWay, and that gives me the fortunate position, FutureWay, that I actually can, look far ahead. I really think this is, you have to sort of, just like you have to work up and down the full stack, you actually have to look ahead far and come back. That's really, almost essential to doing anything in technology that's worth something. And I think very few of us get that opportunity to spend time looking ahead and then come back. So, and because I do that, I think one of the things that is really important is this technology it isn't just hype. We've hyped, I mean, when you make reality a platform, that has huge implications. You must look 50 years out when you think about what that means. And it's really important. That is absolutely huge. But the other thing, to get back to disappointments, I think I've been very disappointed with, you know, some of the fundamental sort of things that I'm very surprised we haven't been more focused on. I saw a wonderful paper recently about using AR in language acquisition. And I think you had a wonderful graph of about, you know, how few people get access to these kind of technologies. And I think that disappointment around the glasses has been, you know, while we won't get our dream glasses right now, we have not, I mean, after cardboard, the kind of idea of a sort of open source modular glass that allowed you to have something that could be used in education and things like that has just sort of whoosh, gone. And now, you know, I actually spent 4 years working with Will Wright and know a lot I've had the privilege of working with one of the masters of simulation games. I feel very sad that we have only focused either on, you know, the use cases that have always been very strong, like you know, industrial use cases. They've been strong here in Germany since the early 90s because there was a very nice funding mechanism. And in the US, there's been a huge focus on gaming. But, you know, I always try to ask myself, where is AR essential? Where will it really solve real world problems? And, you know, I think that has been a sad thing, that after cardboard, we never saw a kind of really cool open source project for eyewear that would allow people to sort of build these other use cases that don't necessarily fit into sort of current business models. So I think that on the glasses note, that's been a bit of a disappointment that didn't happen.
Well, and on that note, thinking towards the future, what do you think is a waste of time? And maybe what's not a waste of time?
What's a waste of time? I think we're wasting a lot of time reinventing the wheel. I mean, if you've been, you know, the first pair of eyewear I worked on was in the 90s. And you know, these hype cycles go up and down, and it's been very exciting to be in this recent one. But I think, you know, just because of the way things work, basically the current eyewear basically was just put together from whatever, you know, was most readily available to whatever company was working on it. There wasn't this idea of really looking at where could this technology, because remember, Ori and I wanted to take this out to a large market. We wanted to take it away from just the narrowness of industrial. Where would this make a really big difference to the world? It's more like, I mean, and honestly, I think it's interesting. I mean, you know, in gaming, it's very obvious that to have that immersive experience will have a huge place and 100% will happen. But you know, a lot of the principle of gaming is actually dimension reduction and making the world playable. And there's a lot of problems to solve when you start trying to think of games, you know, working well in virtual reality. I mean, I think the success of Beat Saber was that they really understood that and found a way to make a game that really needed that experience. So I think that's a disappointment, but I think, so what your question was, what did I really...
What is a waste of time?
Waste of time. It's not a waste of time to work on gaming applications, but I would love personally to see more effort go into, you know, reinvigorating this idea of modular open source hardware so people could think back to the PC, think back to, would Silicon Valley be Silicon Valley if you hadn't had these homebrew computers and all of this? If just suddenly all we had got was like 3 versions of things and no one could modify anything? Or so I think I'd like, you know, I think it's a bit of a waste of time and money for everyone to be doing slightly different proprietary versions of the same thing. I'll end with that one.
I can think of a couple of wasted times in AR. Some of them, I think, to your point, are reinventing the wheel, and others are kind of things that seem exciting. But you know, I'm a huge optimist, so I'd rather have a question. What do you like? Because I love all of it. It's fantastic. But sometimes we focus too much again on the technology. The technology is super important. But then if all you do is focus on the technology, you start looking out in the future too many years, like not 5 years or 10 years, but like 50 years or 100 years. And you hear people talking about, I'm going to have a pair of contact lenses that I put in my eye, and it's got all the electronics, and it was amazing. Like, if we can't, in the next 10 years, have a clear roadmap to, in the form factors we have, just have these things be perfect, like, it is kind of ludicrous to take something that would be like 1/10,000th of the volume and suspect that we could get the power and the compute and all the things that you need in it. And so I think that there should be a balance between what we get excited about, and it's probably because we see things in mainstream media, like why are people excited about AR contact lenses? Because somebody saw it in a movie and thought maybe it was real, and that leads to one of the other things, which is the idea that the minority report interface is how we're going to interact with things. And you know, you mentioned that you repetitive motion, right? The carpal tunnel for your shoulders, right? Like how many? Like if everybody put your arms up like this, how long until you don't want to do that anymore? It was like immediately, right? Like that's the problem. And so when we see these things, we really need to think about the people on the inside. And if we're not, then that's a waste of time.
All right, well, so I'll let you be an optimist now. What is not a waste of time?
Well, I think, you know, really what I would like to, I mean, this was, again, Ori and I came up with this rather kind of ambitious statement, 1 billion users, and this is, you know, to benefit humanity. And that's just, you know, what does that mean? But I think I always had a feeling for what that means. And it's interesting because, again, one of my heroes in computing is Alan Kay. And one of the first, you know, of the legendary demos that changed the trajectory of computing, because Steve Jobs saw them. You know, one of the things that was presented at that time was this idea of real-time collaboration, but you know, full bandwidth with collaboration where you can share media. And you know, we still haven't, as you know, the croquet slide. That's the first, really. I mean, I would say that's the first project that's sort of really showing that there's a potential now to have this real-time collaboration on the web in an open way, just like, you know, the rest of the web works, so that we're actually able to see things and interact with them in a collaborative environment at the same time. It's unbelievable to me that in computing we haven't achieved that, to be honest. Now you take that into AR, VR, and it really becomes, I think, the most essential tool for civilization, because we're at the point in civilization where most of the challenges we face are system challenges of such complexity that no individual can really understand them, interact with them. And again, very influenced, you know, by my time working with Will Wright, the power of simulation to allow people to have the building blocks to understand complex systems is unbelievable. I mean, if you've ever played The Sims, I mean, you learn so much about yourself. I actually learned that it was really, and I was quite young when I learned it, but that it was really good to pay a housekeeper to clean your house. You would really be happier. I mean, I learned that at a point where you had to think about how you budgeted for a housekeeper. But, you know, in a complex, if you think about it, the complexity of our biology and our neurology, the complexity of our world, the complexity of our environment, all of this is happening in real time. I mean, we absolutely, as human beings, need these tools, and we need them now. And again, that's why I said one of the sad things for me was more work wasn't done on what this infrastructure should be. right from the start. And that's why, again, I said we need to think about where we're going, because if you really think about, where you want, human beings to be, we definitely need to get a handle on these complex systems we live in. And it can't be in the way we're doing it now, because we see it every day. It's like policymakers don't understand what they make policy on and all these kind of things. But most importantly, I don't know if anyone's heard of mirror worlds. That initial book written by David Gelernter in the 90s, the idea of mirror worlds, which are what we call digital twins now, or simulations, is to give citizens tools to understand. And again, a bit of sadness is, what does digital twins mean now? It just means really, it's not a networked concept to us anymore. It's an idea that you have a stimulation to build a car better. So I want that. I want these to be our tools that help us manage our humanity, really. And that would be through collaboration and tools to understand the complex systems we live in. But I've got a question for the audience. What is your favorite AR app? Anyone want to proffer? Anyone got a favorite AR app?
Just call them out.
Mine too. Thank you.
Night Sky.
Night Sky. Absolutely.
Wonder Scale.
Oh, yes, yeah. You're from Chris Mill. Yes, yeah, I agree with that. Yeah.
Spatial.
Yeah, U-second spatial, yes. It's interesting because, basically, there should be a lot more of these. And again, I think this is another thing about we haven't quite got the infrastructure business model thing right, because again, what Uri and I dreamed of, that there would be we really tried to support app developers and the whole development community, and even when there were no tools for them. And I think, we do need to have a different understanding so that people are more motivated to build these apps, because, it's really hard for people. I mean, the way things have happened, the tools are sort of, it means you can't really build a business. You have to build a feature at the minute, or your app it's very hard to make a successful business still. But Night Sky is just such a, it's when you can see there should be, I want the birdsong app right now, because, we're facing this crisis, the birds are disappearing. And part of it is because none of us even relate to birds. We don't even, I'm the worst of this. I spent decades in New York City and then in San Francisco, and I've only just moved to the place where I hear the birds. But but this is the power, and imagine language learning in AR. It's so obvious. And all these things. So yeah, we've got this potential, but we haven't quite got, whatever it, actually the infrastructure, the social things, the business things, the ethical things, and the trust things right, yeah. That's why I'm saying this is our work for the next 10 years. But we can't do that in isolation from our roots, which is in engineering and technology. We have to find a way to bridge the language of that, so we can communicate across this full stack.
I guess I would just add to that specifically anything around helping humans connect to other humans and maybe connect in a way that's closer to the emotions they're feeling. I know that may sound unusual or even uncomfortable if you think you're in an industrial or an enterprise space, or you're dealing in spaces where connecting with people and emotions don't normally have a central role. But I promise you, it makes everything much more powerful in spatial computing when humans can connect more closely with other humans. If you're making AR hardware, make sure I can see the eyes of the people that are wearing it, because then I can see their humanity. I can see whether or not I'm connecting to them. If you're making a VR app, help expose your emotion, help people really connect on that level so that we can improve things and make these experiences more. Hey Siri, did you catch that? So that people can connect more closely with other people, other humans. I think anything that we do in that space is definitely not a waste of time.
We've kind of hinted at it a little bit, but and throughout the whole day, the theme has been convergence. And I'm just kind of curious to hear your thoughts. Why is this such an important and critical thing for us to be talking about right now?
Well, just to sort of emphasize what Brian said, that I really think that's the core of it is, and again, this is an Alan Kay quote, is when you change what it means to communicate, how you communicate, you change what it means to be human. And, you know, I think we've got our technology has got very obscure and black box to a lot of people. And I do think it's this magic circle between AR, VR, real-time simulation, collaboration, and again, Turles' talked a lot about holographic communication, giving us new ways to communicate, but particularly thinking about what our real problems are. That's why I really think, and again, I think Alan Kay has some talks up on this. Look at the way he thinks about, you know, these complex problems of humanities. He is probably, you know, one of the most important thinkers on technology and education and how, you know, technology and systems thinking and how our current approaches, I mean, even down to our computer languages, are really quite inadequate for the needs of our communication. And he's done an enormous amount of work on that. And it's quite fundamental. So I think that's, you know, that's really the core. This is about giving us and enhancing the ways we can communicate and collaborate and really focus on these complex systems challenges that our existing structures of technology and communication just seem totally inadequate for.
I think it's important, and the idea of the spatial computing workshop, the idea of a forum to talk about the convergence of spatial and AI and new forms of communications and networking technology was Tish's idea, but it was really easy for me to get excited about it because having seen the industry as a whole grow up, it's clear when market forces drive the development of technology and interaction and business models align and they create opportunities for people to push things together. But when you look at the adoption of spatial computing alongside communications and AI, there's a lot more opportunity and opportunity for things to go really well or things to go really wrong and have challenges that span industries and they span geographies and geopolitical factors that have created a situation where the normal market forces which interact almost tactically are not helping people to think 5 steps ahead and to really create opportunities for these huge and transformative industries to affect each other and to be a force multiplier for each other. And if we could do that in a forum like this, and this, you know, I might have said already, this room is kind of like the first year of the whole event, the event that most people came for that starts tomorrow, was about this size. And that group of people, you know, almost I think everybody from that first year is still in the industry and you still see them and they've all done really amazing things. And if we could get a group of people that were starting a new conversation, that were again looking 5 steps ahead, but beyond a single part of the industry and looking at how these massive transformations could come together to make each other better, that this might be the first forum that was really taking place or that conversation was being had outside of very specific silos.
It's interesting. Just want, because part of it is like, you know, beginning to, I mean, again, part of the vision Ori and I came together on was this idea of building an ecosystem and a community, and Ori's really good in that and has done a lot of the heavy lifting. But I think we now need to broaden our community. I'm interested, hands up who's an engineer in this audience? Hands up who's, I don't know how you categorize things, other categories, but would say they have a background. No, a background in the arts. Anyone with a background in social scientists, politics? Ah, interesting. See, but just one. Just one. It's good that we have the artists, because it's really going to be now artists, scientists, mathematicians, but we only have one person here from some of a very critical part of this. And just think about this. We've just said these trends. It went 10 years ago, mobile first. Now it's AI first. And one of the huge issues of AI is that at the minute, we haven't really, we have a trust problem. Because essentially, for many, many people, AI is totally black boxed, and it's even black boxed, for people, the engineers in some instances. But we have to sort of, you can take autonomous driving as an example, where when you're behind someone who in San Francisco who's kind of driving very slowly and crossing lines, you have you have a theory of what's going on for them, because we understand they're human, they're like us, and we can make predictive judgments. But we need to be studying our machines too. We need social scientists, philosophers, psychologists to be also helping us understand our machines too, so that we can have a better relationship with them and even know what we want this relationship to be. So, what's your background and what brought you here, the one social scientist? Right. Yes. Yes. Yes, which is obviously very valuable role. I just want, again, in my theory of this really looking at everything as a full stack problem, I want us to come together. And again, the thing that I'm a little sad about that we didn't make progress on, think about how should the infrastructure be? From the point of view, there's the beginnings of this kind of work. There's been some, there's the famous MIT moral machine experiment, which, didn't really end up in a place. It just told us that there's a problem. But I think that's really, it's just, Ori and I made a big effort to have artists always involved. Like, I don't know did anyone come to early Augmented World Expos? We always had artists there. But I think now we have to make an effort to broaden, so that we can really discuss some of the hard problems of the future, which are not just tracking, mapping, and registration.
So if this conversation about the full stack and about convergence is so critical to be having right now, why is this happening outside of the main track at AWE?
Because I think at the moment, the conference is still supporting its original community, which is largely a community of developers, artists, industry, and if you're in a startup, it's very hard to have bandwidth for this. If you're in a startup, we've gone all the way. We've talked about AI, we've talked about network infrastructure, we've talked about the future of these experiences. For a startup, that's just way, way too much at the moment for this community. I think it's just not on the agenda at the moment. So I think that's one of the reasons is that it just, this actually, this is my first time at the European event, even though I'm a co-founder of the actual event, the original event. Ori's done all the heavy lifting for the last few years, so I just sit on the board with Brian. So essentially, it's an event that's evolved from a community of developers, artists, and people, working in big companies who actually more or less work in the same model. If you're working in a big company, you actually have some of the same requirements as a startup to kind of come up with something in the near term. And I think when early ARE, we did this, but we did it in the very design fiction way. We had all the wonderful science fiction thinkers and writers. Werner Vinge is an absolute god on this, and honestly, you have to just, he has predicted so much of this. He's also a computer scientist. But design fiction isn't enough. I'm actually calling for something a little more. We have to bring science in and study these problems too. And we have to begin to sort of bring this into the loop of our conversation. And I think that's partly this event, is to figure out how to do that. And I'm not sure we know yet. And I do not think, I'm not sure, I certainly know, I don't know because this is my first experience at the European event, but in the US event, I mean, we do things like this in the tracks, but people are really mostly working on a fairly short-term cycle. And to ask people to look at these sort of full stack issues is still something we have to figure out. I don't think we have a plan yet, is what it is. We need a plan or an idea of how we grow this ecosystem, which has to work across silos of thought, which I'm saying policy, philosophy, ethics, all the way down to the very hard problems of AI and perception. And remember, we made perception 10 times harder now, because now perception is supposed to make predictions and all of these things. So I think we haven't really haven't really got a way yet to energize this as a ecosystem. And as Brian said, hopefully people who've attended this workshop, and hopefully we'll set up a way for people to have some kind of mailing list and input, their input on how to do the next events in this area. But I think we're just right, we're looking forward and we're figuring out how to do it. But I'm not sure we've quite got a plan how to build the ecosystem. I mean, who are the stakeholders? How can we, build this, really?
Yeah, I don't know that I could add a lot to that, other than, just to sum it up there, as a panel or a track at the main event today, it doesn't draw in the new people, the new constituents, the different parts of industry that aren't participating in AWE, that aren't participating in AR or spatial computing generally. That's businesses, that's government and policymakers, that's everyone that needs to be really thinking about these things for us to really make progress. And then ultimately, it does feel like it just has a natural home as part of the track, or maybe just helps to shape the way the industry thinks about these things as a whole.
I think even sort of once you name something like the full stack of or the challenges of spatial computing as a sort of holistic problem across, a full stack, that's a different way of thinking about it. And I do hope that we begin to sort of work together, but we don't have many vehicles for this. I mean, that's why I was saying one of the sad things was that wasn't, something like cardboard didn't evolve into sort of a full-on open source modular hardware concept that could have become the platform for people to experiment with this. Because, see, at the minute, most of the experimentation is just geared to existing markets. That's why gaming is a focus. It's obvious. I mean, if you've ever played a immersive game, it's obvious that eventually it will do well to be an AR or VR game. That's kind of a no-brainer. Whether that's going to be a market soon or when, because there are issues with that. But what's much harder is to get, a community of stakeholders together now to look at some of these sort of missing use cases like communication, collaboration. And to be quite honest, we've only just begun to get some tools like croquet. Has been going a long time, but this is the first time they have really solved this problem of real-time collaborative immersive experiences. So, I suppose it's partly that. You need to present, some platform. We need platforms. Then you can begin to get a community around it. I think it's only kind of hardcore inner circle people who will begin to think about this in the abstract. I think that's really another thing we have to work on platforms, which, again, as Brian talked about, they are making a platform. And we talked a little bit in the break. I talked to you about she asked about, well, how would this help blind users? Well, that's exactly what platforms help. It's very hard to develop a niche experience right now because, you've got no platform really that's, open to all of these possibilities. We've got very focused platforms. Yeah. So I think that's the sort of missing piece. We need more to offer people to make this discussion exciting.
Brian, you mentioned that at the very first ARE event, it was a audience size about this big, and now it's grown to this massive worldwide phenomenon, sort of. I think a nice way to wrap up everything we've been talking about today is how can everybody in the audience go out and help continue this conversation and help move this work further so that this continues to grow and grow each year?
So I think that the things that we do in forums like this are an invitation to continue the conversation. There'll be a follow-up for the people who attended to join a mailing list and to share the conversation, to influence how other workshops and how this track shapes up and hopefully continues on in future years. Personally and as an organizer, I'd love to have everyone here share their thoughts and see how we can make the quality and the development of this conversation to really move into the future. And I think that's really important because all of this is a great conversation. It's a great way for us to network and maybe meet people that we can work together with. But if we can also think about how we can move the conversation overall forward, that would be really powerful.
Yes, and I agree. And I hope what we do is when we have presentations of the sort of early stage of things like croquet, I hope things grow out of that, and next time we invite some people to talk who've actually built on that experience and things like that. And I do think we want to encourage these platforms that allow these new experiences, and I think it will begin to gel. Just like actually Ori and I did not. I should really say we didn't just begin Augmented World Expo at ISMAR 2009. Actually, Ori and I separately had just been blogging, going to meetups. We were probably the only two. I lived in New York City then. We were probably the only two people who were constantly raising augmented reality. And I used to say, anyone heard of augmented reality? 0 hands. 0. Yeah, you know that. 0, you remember that. And we actually met before ISMAR because he had a blog and a startup. Games Al Fresco was his blog, and his startup Augmento. And I was blogging, but also working in industrial VR. And it takes a while. I mean, he and I were lonely voices for a while, although, I was very confident because remember, I never said this, but I began in visual effects, and my first startup was a 6 Degree of Freedom motion control robot that layers AR on film. So I have a very long time knew what the conditions would need to be for this to become an experience outside of film, and literally the day I unboxed my first phone with a GPS and etc., I knew there was a chance. And so it takes a while. You have to be a lonely voice for a while if you want to really sort of build these things. So we're quite a small voice in a small group, but it really did not grow from the ISMAR moment. Ori and I had much more lead time of being, just a few people. And Brian too. Brian's had very important experience in early AR.
Thank you.
Yeah, it's true. Very, very true. Does anybody in the audience want to ask Tish or Brian a final question before we wrap up the day? All right, well, I just want to thank you for your participation. Thank you all for your participation. Thanks for spending the day with us, and hope that you have a great experience at AWE this week.
Thank you.